Okay, so today's Thursday, April 1st. I'm not really a kidder or anything like that. So nothing's going to be an April Fool's kind of thing. Anyway, but I'm really glad to see you again. I haven't seen you for a few weeks. I hope you had a restful break and also were able to catch up on schoolwork. Also, I hope you had fun with Carl, where he introduced electrical engineering, software engineering, and computer engineering. And today, what we're going to be covering is agricultural engineering, manufacturing engineering, and industrial engineering. But before we go into that, and we're going to have a collection of speakers and everything, it's going to be really fun. Before we do that, though, I just want to, give an overview where we are now. So I'm going to share my screen. And if you notice, I'm going to scroll down. Here was spring break. This is our first week back from spring break. So we're looking at class 9 right now. After today, we only have 2 more classes. Class 10 is all about being employed as an engineer and working as a professional engineer, and ethics and social justice. That's all has to do with employment. And then our last class is when we're doing presentation wrap-ups and a course wrap-up. So what I want to do first is go into the assignments. And I know you don't have access to this page, but you have done all the assignments already. So this is just how Priti and I had organized the class. But notice you did homework 1 and quiz 1, number 2, 3, 4, 5, 6, 7, all the way up to 8. And they covered the 8 chapters in the textbook. So you have submitted all your homeworks and quizzes for those 8 chapters. We are going to have 1 extra homework assignment, and I'm going to talk to you about it in a little bit. And then there are 3 project assignments. 1 is the interview and engineer project. 1 is the Mobile project with Priti assigned 3 weeks ago. And then there's a project, it's called a project. It's not really hands-on. It's more of a reflection, and I'll talk about that in a little bit. Okay, so what I'm going to do right now is go back to our module. So I'm going into today's module since this is what we're going to be working on today. So I'm hoping that everybody could see the module. And what I'm doing is I'm going down to assignment reminders. So 1 is you need to interview an engineer. And almost all of you, I gave someone to interview already because you came and met with me. But a number of you still need to meet with me. So the ones who need to meet with me is Alejandro, Carlos, Crystal, Jasmine, Kevin, and that's it. So there are a few of you that still need to meet with me. And what I'm going to do right now is I'm going back up to class 4 for a moment. Class 4 is when I assigned the homework of interviewing an engineer and meeting with me. And there was a discussion where you're meeting with me over Zoom for 30 minutes. And what I'm going to do right now is I'm going to open up that assignment, and meeting with me was due on the 29th, but I'm going to change it. I'm going to change the due date to April 12th. So that means you have until April 12th now to meet with me. And I'm going to change this to April 12th. Okay, so those of you who have not met with me, you still have an opportunity, and you want to come and meet with me in my office hours. And just as a reminder of where my office hours are, if you go into week 0, it says in here, instructors. So if we click on instructors and you scroll down to me, Joanne, you'll see that my office hours are Monday, Tuesday, Wednesday, Friday, 1 to 2 in the STEM Center. And here's the link. So those of you who have not met with me yet still have an opportunity to meet with me to get credit for that discussion post of 4. Okay? Okay, I'm going back to modules. So I'm gonna minimize week 0. And you'll notice now when I refresh, that for class 4 engineering education, where there was that discussion of meeting with me, now the due date says April 12th. So the 5 of you who haven't met with me yet still have an opportunity to meet with me. And you want to meet as soon as you can, because if you do want me to give you an engineer to interview, you got to do it really soon, because we have to give them enough time to be available. Okay, now I'm going back down to our class. Am I going at a good speed? I don't want to go too fast. Everybody, could you give me a thumbs up or a nod?
Doing
Everybody
fine, Joanne.
Cody, what was that?
Yeah, doing fine.
Fine, okay, good, thumbs up. Okay, so I'm back in class 9, which is today. And so you know the interview of an engineer project. Somebody asked me about the Mobile project. So since it was just introduced a few weeks to you by Priti, I would like to go over that again. So I'm going to open up the Mobile project. And really what the goal of this project is for you to think about what you know from your own life in terms of engineering and what you learned in this class, and really think about what it is that who are you, and what is your interest in engineering. So it says, the goal of the project is to design and build a mobile with items that represent you and your interest. A minimum of 4 horizontal supports can be used, and you could use skewers, but students have used many other things in the meantime, in the past. The entire mobile must be supported by 1 string. No horizontal support can be supported in the middle. So in the case right now, I have a pen here. This would be a mobile whose horizontal support is in the middle with things hanging from the end, and we want the supports not to be supported in the middle. So you have to put the heavier thing here and the lighter thing here for it to be balanced. And then you hang items from the mobile which reflect you and your engineering interest. For example, you might have CDs on it for computers, electrical components. You basically could suspend whatever you want from it, including photos. I mentioned to the students who came earlier today, I had a student who's interested in designing bridges. So she took photos of bridges and suspended them from the mobile. So they don't have to be real items. They could be pictures of things. And then you need to create a report, and the report has a title page. You need to have a photo of your mobile, discuss the important items, and then draw a 2D sketch. I know that some people have done a 3D sketch, and that's fine too. And you need to have parts numbered and a parts list. And here are the grading rubric. And then we have a bunch of examples of different mobiles. So I'm going to stop sharing for a moment and see if anybody has a question about the mobile project. So on the day that you're going to present it, you're going to hold up your mobile and say, my name is Joanne. My interest is in civil engineering. And on my mobile, I have a picture of this bridge in Dublin that I love. And I have a pencil on it because I always use mechanical pencils. And I have a this on it, and I have a this on it. And this is a picture of my family who has had an impact and supported me while I was going through my education. And that's what you're going to be doing on the last day of class. Okay, questions? No. Okay, good. All right, so I'm going to go back to our module. So I am back in our class 9 module. So the interview the engineer, mobile, and then this is the 3rd project, and it's not really a project per se. It is another reflection. So I'm going to open this up. And you may have had this presented to you already by Priti or Carl, but just in case, maybe you're just seeing it for the first time now. Okay. Carl wrote this up. It's really interesting. Fear melts away. Fear melts when you take action towards a goal that you really want. Now is the time for you to make an action plan. Even if you're not sure about your goal, make a plan now and revise it later. So the goal is really for you to think about this class and which field of engineering you want to go into, or which fields you're still exploring. Or if you decided that you don't want to be an engineer, you're reflecting on which area of your career you would like to go into. So you're going to research, write a 2-page paper and submit it online, review the formatting guidelines below. Basically, what educational goal are you committed to? Are you still not sure? Then list the options you're considering. What is the best plan? Why do you think this is the best plan for you? Who you are, what you want, what things you care most about, what you enjoy most, and then make a step-by-step plan for accomplishing the goals. How long will it take to reach your goal? Estimate the cost. How will you pay for these expenses? Remember, we've talked a lot about scholarships. There's a ton of scholarships on Cabrio's page. And then what benefits do you expect to gain? So you're going to keep this and refer to it often. It's going to be a guide. It's going to be a guide for your action plan on taking your classes at Cabrillo, transferring, and what your career goals are. And a lot of this assignment you've done already. You looked at what a dream job could be. You met with me to look at a schedule. Numerous times in the homework, you've referred to which fields of engineering you're interested in going to. And just again, those of you who decided you don't want to go into engineering, then you write this up for non-engineering, because we don't want you to talk about engineering if you've decided something else. We want you to think of what your true action plan is. Okay, I'm going to stop sharing. Any questions on this? Questions? Let's see who else is here. Hi, Oscar. Hi, Kens. Hi, Alex. Hello, Reed. So those of you that missed a little part of the beginning, I recorded it. So make sure you watch it because I'm giving you an overview. Okay, I'm going back to sharing again. Okay, so you will not have a homework assignment today. Notice under today's class 9, April 1st, under assignments, there's no homework. We are not assigning a homework. There is a short discussion like usual, but there's no homework, so you could start concentrating on the projects that you're going to be working on. There is only going to be, and I'm going to go to class 10 now, there is only going to be one more homework assignment, homework 10, which is going to be about the topics that we cover next week. But notice it says it's optional and it will count as extra credit. I noticed doing the grading that some of you have missed some homework assignments, or maybe you got a homework assignment where you didn't do a complete job and you only got a 4 or a 5. Basically, we chose this homework assignment as optional. You could do it if you want, and if you don't want, you don't have to. It counts as extra credit. Basically, it counts towards a missing homework or replaces a lower homework grade. Or if you've gotten all 10s already, then it's still going to count as extra credit. So although there is no more required homework assignment, next week I will assign a homework that is optional, and it'll be due like every homework assignment on a Monday or late Tuesday or late Wednesday, and it will count towards an assignment, but you do not need to do it. Okay? And then, so the only thing due on class 11 then, I'm going to open up class 11, are our 3 projects: the interview and engineer, the Mobile project, this reflection, the future you see project, and if you decide to do the homework, the optional homework. So on class 11, our last class, you're going to present a highlight of something you learned when you interviewed the engineer. you're going to present, and you're going to present your Mobile project. And we're going to do a fun Kahoot project in class. And then we're going to get suggestions from you on what things you think should be kept in this class and what we should change for the future offerings of the class. Hello, Ruben. So again, today's topic is agricultural engineering, industrial, and manufacturing. Next week, you have me again, and we're talking about post-employment, employment stuff, post-education, employment stuff. And then the last class day is when you're going to present your projects, and we're going to talk about, get suggestions from you. Okay, so I'm going to stop sharing again. So hello, Carlos. And anybody else who just came in? Okay, so a few of you just joined us. I recorded our lesson, our class today. So make sure that the last 15 minutes that you missed, you please watch that. And now what I'm going to do is I'm going to begin today's topic. And soon we're going to have a presenter arrive. Oh, and Alejandro's here. Great. Okay, so I'm going to go back to sharing. And I'm on class 9. And what I'm going to do now is I'm going to open up my Ag E, Industrial E, and Manufacturing E slides. And I have to move all your faces to the bottom so I have room. And there. Okay, so everybody should see my PowerPoint slides. Thumbs up from somebody. I only see Cody, Ruben, Julio, and Carlos.
Good.
Okay. All right. So just like I began the chemical engineering and the materials engineering lesson, I wanted to begin the agricultural engineering lesson the same way by introducing you to the website for the American Society of Agricultural and Biological Engineers. This is the technical society that all engineers who are ag engineers or biological engineers belong to. As I mentioned before, these technical societies allow students to join for either free or 10 or 20 bucks a month, a year, I'm sorry, 10 or 20 bucks a year. And what's really cool is they have magazines where they talk about cool projects. They have scholarships for students. They invite you to networking opportunities where you could go to a dinner or a conference, and things are online now, so they're very convenient. So I wanted to first mention what the Technical Society is for agricultural engineers. Then I wanted to give you an overview of what we're doing today. So for the ag section, first we're going to have Sarah Hewlett come, and she was working at Cabrillo, and she was running the ag tech program at Cabrillo. She started new classes, and she's going to introduce you to what agricultural engineers could do. And then as a follow-up to that, I'm going to have a video recording by Peter Shaw, who's the chair of the horticulture program at Cabrillo. And he has started a lot of also ag engineering projects up at the horticulture facility. So Sarah's going to talk to us with slides and in live, and Peter is going to show us a video. I would have, if we were in person, brought us all up to the horticulture place to have a tour. So we're going to have a virtual tour because of COVID. Then I have a PowerPoint presentation by a Cabrillo Engineering alum, Keenan Roop, who put together a presentation of what is agricultural engineering. And I'm going to show that to you. And then finally, I'm going to talk about what the engineering abroad students have done in Costa Rica and Guatemala, which have been main agricultural and biological engineering projects. And then I'm going to tell you about these two programs. Okay, so that's what our first ag engineering part is going to be. Then Sarah is going to come on, and she may actually be on with us already. I'll take a look in a minute. We're going to watch the video by Peter Shaw. We're going to watch the PowerPoint slides by Keenan. I'm going to talk to you about the abroad programs, and there are some videos that you could watch on your own time. And then we're going to move into industrial and manufacturing engineering today. And again, I'm giving you the technical society links for those two technical societies. And then we're going to watch an industrial engineering video on what is industrial engineering. Katie Griffin is a past engineering student who got her degree in in industrial engineering about 15 years ago. And she couldn't come during our class, so I met with her and did an interview with her. So I'm going to show you that video. And then there are two other industrial engineers that are alums that wanted to speak to you as well. One of them will be live for you in the earlier section of Engineering 5. Graham is going to come and join us, and he's going to talk to you live. And then James is going to talk live to the next section, the 6 to 9 section. And then you're going to get an opportunity to watch James's video. And then the later section will get an opportunity to watch Graham's video in the discussion. And then we're going to look at some manufacturing that's done. And I picked candy canes because we had so much fun with the candy a few weeks ago. I figured I'd show you how candy canes are made so you could see what a manufacturing facility is. And then here's Katie's video. And then we're going to hear from James and Graham. So that's our schedule for today. So I'm going to stop sharing now and take a look to see if Sarah joined us. And she has. Hey, Sarah.
Hi, how are you guys today?
Sarah, it's really awesome to see you.
You too, Joanne. I'm so happy to see you again. The pandemic has made time fly by, right?
Yeah, it has. All right, you guys, if you're comfortable showing your faces, it would be really awesome for Sarah because it is really hard to teach to a bunch of names written up there. So if you're comfortable showing your picture, that would be really awesome. And Sarah, I am recording this. I think you said that you can come to the evening section, but if for some reason you can't, I could show your video. So you could let me know at the end or now if you have time or not to come to the evening section.
Okay. Yeah, if you're recording, no, I'll come. I think it'll be more fun for everyone.
Okay. All right. Thanks, Sarah.
Yeah.
Okay. And now what I'm going to do, Sarah, is I think I need to pin you so that students see when the video will have you and what you're showing in your screen rather than when other people interject and ask questions.
Okay.
All right. So I'm going to turn it over to you, Sarah. Tell me what, yeah.
Okay. And bring your shared window to the front. What are you guys seeing?
What I see is I see your presentation, but it's a little skewed.
That's what I see as well.
Does it look like it's in PowerPoint or does it look like it's in Chrome?
Now it's okay.
It's in Chrome.
It looks like
somehow I've ended up in Chrome, but I think we can work with it.
Yeah, I think it looks great.
Okay, super. All right, well, hi everyone. My name is Sarah Hulick. I used to work, oh, there we go. Okay, I'll have to be careful. So I used to work with Joanne full-time at Cabrillo, and I still work at Cabrillo a little bit doing some curriculum writing for career and technical ed. And just so you guys know, I can't actually see you anymore because now all I'm seeing is my screen. So maybe you can just speak up if you have a question. And so I am a plant scientist by training. And my background is I grew up on a farm in upstate New York. So I always tell people New York is actually really similar to California, where there's a city and some like major metropolitan hub. In California, there's two, there's San Francisco and LA. And then the entire rest of the state is literally like farms and mountains and stuff. And New York is the exact same way. So there's New York City, and then the whole rest of the state is farms and mountains. And I'm from a small farm in upstate New York. And then I went to college at Cornell University, which sounds very fancy, but honestly, if you're from New York, going to Cornell is kind of like going to maybe like UC Davis here in California. And they do have the agriculture school there. So I went to the Agriculture and Life Sciences School and studied plant science. And then I got my master's degree from there also in horticulture biology. And the reason I got my master's is because I basically like wanted to be a scientist. That was my goal. And I love growing plants and I love feeding people. I love food. And I always kind of wanted to make sure that people had enough food and that there was more food for everyone to eat. So that's kind of my background. And then after I finished my master's degree, I got recruited by Driscoll Strawberries, to move out here. And so that was 8 years ago in 2013. And I got recruited pretty much straight out of grad school to come take a job with Driscoll's. And I moved to Santa Cruz County, and I've been here ever since. And I just love this area because there's so many really good jobs. And that sounds funny, but talk about adulting is like you just want to like live somewhere where it's beautiful and the weather's good and there's great jobs. And for me, as someone who's in agriculture and in agriculture science and ag tech now too, this is where like the best jobs in the country are, for sure. And there's something really beautiful about being at this kind of nexus of production agriculture and next to Silicon Valley. So currently my job is grower innovation manager at an ag tech startup called Full Harvest Technologies. And Full Harvest is basically trying to build an online marketplace to buy and sell produce online. And right now, produce is bought and sold. You think about Amazon and you just go on and buy a t-shirt and you want the purple one and you want it in a size medium. And it's like that simple. And it shows up at your door 2 days later. Produce isn't like that. It's all, old guys calling each other saying, I want 40,000 pounds of mandarins. Well, too bad they're stuck at the border and you can't get them till next week. And it's very like hands-on and all on the telephone. And so basically Full Harvest is trying to disrupt that. And so I made this slide deck a couple of years ago, and all the pictures in it are from Cabrillo. So this is very much like what is happening at Cabrillo. But I would say now that I've worked at Full Harvest for a couple of years, I actually have a very new perspective on like software engineering and ag tech, which isn't really encompassed in this deck. So I would like to share that now. And one of the things I realize is like, to be a software engineer, to be a hardware engineer, you can work on anything at all. Like, you can be a software engineer and work on automating, in and out orders at a hand sanitizer, manufacturing facility, or you can build anything, you can work. But so what I would say, what I think you all should think about is, if what I want to do with my life is coding, if that's what I love, or if I'm really into like optical stuff, well, what do you want to do with that? Like, what industry do you want to be in? And you can do like optical, audio visual engineering stuff. And you could do that for drones, for the military, or you can do that for like, in this picture that's on the screen right now, you can do that for like, optimization of crops in a greenhouse so we can feed people better and we can be better responsible stewards of all the inputs, all the fertilizer and pesticides and everything else and water that's being used. So it's kind of like, you guys all have as future engineers and current engineers, you have this like really amazing skill set. And then what are you going to do with that in the world? And like, you can, same thing, like if I was talking to students in the accounting program, you're going to crunch numbers anywhere, but what industry do you want to make better? Like, what is your stamp you want to put on the world? So for me, I think agriculture is an amazing industry to be in because it's like one of the world's biggest pressing problems is basically like, how do we decrease the environmental impacts of growing our food? And there's this organization called ReFed, it's REFED, and they are kind of the current leader in understanding food waste and agriculture impacts on climate change. And their newest set of analysis is showing that decreasing food waste is actually the #1 way to decrease climate change effects in like the next few years. So all of their stuff is a roadmap to 2030. So it's like in the next 9 years, what are the things we could tackle that would decrease the effects of climate change immediately? And so their top one is decreasing food waste. And that requires a lot of different types of engineering. You could focus more on water, you could focus more on harvest aids, on which is more hardware, you can focus on software. There's like so many, you can focus on chemicals. There's so many different areas that tie into that. And like I talked about before, 11% of jobs in the US are somehow related to agriculture. And this location is a really amazing one to get really good jobs. So these are actually the greenhouses up in the horticulture department at Cabrillo. And we do a lot of really cutting edge research on LED lighting, and even beyond the visual spectrum of what humans can see, UV lighting and things like that to really optimize crop development. And there's a lot. If anyone in the class is from South County, from Watsonville, you see the fields and fields and fields. And some of you may be familiar that there's actually quite a labor shortage for agriculture, and those jobs are really hard and really backbreaking, and people don't want to do them, and rightfully so. And there's a lot of companies that are developing these automatic pickers right now, and that is going to be the future of agriculture. I do not think in 20 years we'll see a lot of these, even these really fragile crops, being picked by hand. I think they'll all be picked by robots. Because the people are not there, and we just need to automate so that the crops can keep getting produced, basically.
Sarah, could I interject for a moment?
Yeah. Uh-huh.
I wanted to mention that when Sarah talks about the automation that's happening in picking, so what the United States is trying to do is to train more people on the technology, because there are going to be so many more jobs in technology that, as just like you guys sitting in Engineering 5, the more engineers, the more computer scientists, the more people we train in education and technology, people are just going to have those kind of jobs instead of the back-breaking jobs of picking.
Yeah, absolutely. And that is the goal. There's a new Joanne led this charge of creating a new sustainable agriculture technology degree at Full Harvest, and that's what I worked with her on there. I'm sorry, at Cabrillo College, excuse me. And it includes the How Things Work class from engineering, and it includes some programming classes. And actually now I think we settled on Python as the language that we thought was the most kind of cohesive for most agricultural applications. And this kind of skill set where a little bit about producing food, or at least just kind of like the operational aspects of what's important, but actually being more of a computer scientist or an engineer is really, really key. And the images on the screen right now are, this is all at Cabrillo. And we have aquaponics set up, and in the picture on the right, all these cages, and I mean it's hard to see because it's from so far, but basically this is all, we're using all sensors to determine what's happening right in the ponds that we're growing the lettuce in, and in the fish tanks that are feeding. It's like we feed the fish poop, and the fish poop feeds the lettuce, kind of thing. And so 5.7, that's like the pH. So that's the acidity of the water. And, we're monitoring all this stuff in real time. And that's that kind of skill set of like, who can set up these sensors, who understands, who can interpret this data, and then who can make an operational change based on that. These are all the things, this is what, farms will look like in the future. And this is the stuff, I get really excited about it. I hope other people find it exciting, because we're definitely gonna need people to be, these high-tech ag tech engineers and ag tech technicians moving forward. Great, I think I already talked about microcontrols and sensors. There's energy monitoring going on in one of the greenhouses. I think Karen Grappi was leading that a couple years ago. I'm not sure if it's still happening. And then we have a new vertical farm too, where everything is indoors completely. This is the outside. It's not as exciting. It just looks like a box, but inside it pretty much looks like this. I think we have 3 layers in there, and literally just figuring out how do we grow plants completely indoors, and just like kind of problem solving. And you got to think about how much water plants need, and water is really, really heavy. And so that's a very interesting engineering conundrum, is like, this is Cabrillo, and this box is about 12 feet tall. But think about, they're actually retrofitting huge warehouses with 10 layers of this, and then you actually have 1,000,000 pounds of water in that vertical space. And how do you kind of solve for all of those issues also? And then if you're more interested in this, I have a couple, and Joanne can share this slide with everyone, because I know we're going really fast and there's a lot of information here, but there's a couple classes listed at Cabrillo that might be interesting if some of this stuff is really like kind of intriguing you all. And then we've got a few more, I've got YouTube video links in throughout these slides too, and you can take a look at some of this stuff a little bit more. This is my email. Currently, I'm no longer the agriculture technology specialist. I think my current title is career and technical education consultant or something like that. But this email is still correct for me. And I'm really happy to answer any questions anyone has. And then this is actually, here's a perfect engineering problem right here. This is me in a greenhouse I used to manage in Marina. And we are growing that lettuce, which is the type of stuff you'd see in those fancy bags of lettuce. And we didn't have a way to harvest it other than, this is me bending over in a terrible position, my back would hurt at the end of the day, cutting it with a turkey carving knife. And so what we really needed was a whole set of like rollers, so that these channels could roll around the greenhouse and go through some sort of automated cutting machine. And that was kind of like our future hope and our future goal, but we didn't have kind of like the capital and the I'm a plant scientist, so I know how to grow that lettuce, but I don't know how to build an automatic cutting machine. And that's kind of what we need some of you engineers to hope to want to do someday, is to optimize some of these newer technology systems. I'm going to stop sharing so that I can look at you all, and then I would love to answer any questions. All right. I know that was fast. I kind of talk really fast because I'm also from New York, like Joanne. But any questions you guys have?
So Sarah, I know you sent me the PowerPoint, so I could post it on the Canvas page for everyone. So
Yeah.
I'll do that.
That'd be great.
So what are some questions, you guys?
I just want to say thank you. That was a really fascinating. I had never even thought about robotics and agriculture before. That was really cool. I'm kind of interested in what is it? Mechatronics. I'm thinking about getting into mechatronics. So I hadn't even thought about that aspect of it. Thank you.
Yeah, absolutely. And for sure, this area we're in is the hub for ag tech. So there's Salinas is basically the ag tech hub in the US, I would say, just because of its proximity to Silicon Valley. So, the investors and all the big bankers and everybody can come down really easily. And you have access to fields and space so people can test their new ideas. And a few of the things I've seen recently that are, really interesting is like, there's this new sprayer where they actually use magnets so that they can get the water droplets to be the exact same size and go an exact distance in the field. There's a lot of software stuff, because a lot of times farms aren't actually optimized, honestly, about what's your forecast, what's going into a cooler, what's leaving the cooler. And so right now, I'd say there's a lot of actual software companies that are literally just doing that kind of like, we have X tons of this, we have Y amount of packaging, so-and-so needs to get it to, Z field by Monday. And that kind of like operational efficiency software. There's a couple of companies like that based in Salinas. And then every single one of the huge ag companies like Dole or Taylor Farms or companies like that, they build their own harvesting equipment. So they all have like When I worked at Dole, I was an agronomist, and we were underneath the same kind of group in the company as all the engineers. And they would build their own, literally from scratch, harvesting machine to like harvest celery. And so, and like those are very good jobs. It's very interesting work. You're being asked to invent something new like annually. Like, oh, good, you made that for us. We love it, but we want it to look like this next year. And so there's actually a ton of ag tech and ag engineering going on in this area, I would say. And I live in Watsonville, so I'm not calling in from some other part of the world either. So, I've found lots of great ag tech jobs right here.
Sarah, I love what you said about, you could get a degree in programming and then you get to choose what industry you want to work in. And we've talked a lot about that in engineering with these broad jobs like chemical engineering or software, where you get to choose. Do you want to work for the military? Do you want to put food on people's tables, And I think at Cabrillo, because our engineering program is all about humanitarian engineering and engineering is a helping profession, I think a lot of students come to Cabrillo because that's what their interest is as well.
Yeah,
All
absolutely.
right, do we have any other questions for Sarah?
Well, I just throughout the presentation of how different companies use like for example strawberries, and they have different varieties, how they use the chemical processes of making, let's say, from red strawberries to like in a sense bigger strawberries or lettuce. And I thought that was really interesting because it requires a huge process of actually just getting something to be something else. Like for example, you wanted something that's going to be able to grow in a rigid place, or if you want something that's from a dry place to be in a humid place. And I thought that was super interesting.
Yeah, absolutely. And a lot of that, and I'm sure all of you are very aware of, climate change is real and it's happening today. And I've only lived in Santa Cruz County for like 8 years. And I feel like I've seen differences, and the summers are way hotter now. And even today, it's going to be like 75 degrees today. Like that's not normal, right? For we like live on the coast, it should be more mild than that. And so I think what you're saying, Luis, is like, these things are changing, and a lot of people will be getting paid, having careers, and figuring out how do we optimize those changes.
Sarah, I just saw Carlos said that, he feels like the winter is getting shorter, that he's experiencing it too. What about, I think, Luis, you mentioned something like genetic engineering, genetically modified, like making the best strawberries. Could you talk a little bit about what that's like? Or
Yeah,
like
sure.
making a better strawberry, that has to do with plant science and engineering together, or no? Or making a better tomato, or?
Yeah, this is a great question. So I would say, the tradition, there's like plant breeding is what we're talking about when we're like, oh, we're going to make a strawberry that's slightly larger, or it can deal with slightly drier weather. And there's a lot of traditional ways to do this. Like this is what humans have been doing for millennia, right? That's why it's really weird to think about, but like broccoli, cauliflower, cabbage, Brussels sprouts, those are all the same like species. It's like humans have, oh, we like that this one has the bigger head, so then we just plant that one, and this is called traditional plant breeding. And that's still what is the most common today. But there is genetic modification happening, I would say, more at like research universities and more like institutions like that. But and that's really more of a traditional plant science background, but where an engineer comes into this, and this is what's really interesting too, is what plant breeders are trying to do is create the best plant for any given environment. But now that we're getting more into robotic harvesting or growing in greenhouses, those environments are shifting a lot. So they'll use someone with an engineering or a systems engineering background to figure out the perfect combination of environment plus the genetics of the plants. So, for example, strawberries had always been grown in the ground until very, very recently. And then a couple of years ago, they started actually growing them in these like channels that are actually at like waist height in a field. And part of that was for harvest efficiency so that people don't have to bend over to pick those strawberries. But really, you know, if we really think about where is this going to be in 10 or 20 years, there won't be people picking those. So what we need is, you know, those channels need to be designed in such a way that eventually a machine can pick them. And a lot of times you're going, it's like very incremental. Okay, now we have the channel, but there's still people picking them. Okay, well now we need a new variety, or you know, this is like a breed in dogs. We need a new breed of strawberry that actually has a longer stem, so it falls below the channel so that something can go through and clip it off. And this is like the interface of where the engineers and the plant breeders basically interact to figure out what does the hardware and the optical software, what does all that look like with our best plant genetics to make the whole system work.
That's so cool. So cool.
Yeah, it really is.
It really is.
There are so many problems to be solved, and I think a lot of them are really fun in agriculture.
Yeah. Yeah. Okay, Sarah, I'm going to say thanks so much. And I'll see you this evening in the other class.
Cool. Great.
Okay.
Thank you, Joanne. And thank you, all of you. And hope you're having a wonderful Thursday. And hope I convinced maybe one or two of you to think more about ag as your engineering focus.
Thank you, Sarah.
All right. Thank you. Have a good one.
Thank you,
Have a
Sarah.
Thanks, Sarah. Well, I found that really cool. And I think what comes out for me is that the fact that we do live in a great place, most of yours families are around here. Ag is big, it's huge here, and the whole idea of agricultural engineering is new. So there isn't a lot. Like I mentioned, Cal Poly San Luis Obispo has an agricultural engineering degree, and UC Davis has an agricultural/biological engineering degree. There are only 2 universities in California that have agricultural engineering. And we're in such a great place for jobs that I think it's going to be a growing field. It's growing already. And it's something to think about. And you don't have to get an agricultural engineering degree. I mean, she was talking about things like that mechanical engineers do, or software engineers do, or environmental engineers do, or mechatronics engineers do. But you get to choose the industry you want to work in. And if you'd like to work locally, that's a really great industry that you could go into. Okay, so I'm going to move on, okay? Go on to the next thing. All right, so I'm going to share my screen again. And the next thing after Sarah is to hear from Peter Shaw. So I'm going to close this. And let's see where Peter's presentation is. Now, you're going to see some duplicates of photos, but this is a video. So you're going to see it's a tour. Peter's basically walking around with I guess probably his phone, not a camcorder, and actually doing this video. So I'm going to start it. And I think I'll just have it on normal speed. It's 28 minutes long. But if we feel like he's going too slow, I think I'm going to speed it up just a little bit. Okay. So I'm going to change the speed setting, playback speed instead of normal, make it 1.25 and see how that goes. So then it'll only be like 20 something minutes long. And let's see how that goes. All right. And then you could always watch it slower. All right. Hang on a second. Okay, I first want to increase the volume because I feel like it was too low. So let's try the volume now.
This is a video of the Cabrillo Horticulture Ag Tech Greenhouse. You can see that we've got a crop growing in a lot of it.
there's no sound anymore. It's probably because you're muted.
Ah, Thank,
Yes. Mhm.
sorry, you guys. I muted myself and I wasn't sure if it was going to mute the video, but nobody said anything. So I figured it was fine. So I'm going to go back now. Okay. And hang on a second.
Video of the Cabrillo Horticulture Ag Tech Greenhouse. You can see that we've got crop growing in a lot of it. The other parts are going to get planted up pretty quick. But rather than talking about the plants, I really want to talk about the greenhouse structure and the technology. One of the things that you might have seen in the initial video here, the video, is our solar panels that are on the roof. These were manufactured by a local company out of Scotts Valley, and they use the energy of the green wavelength in light to generate power for those power cells. And the red film that this is all manufactured into helps transmission of the red light, which is a very important one for photosynthesis. We have solar panels on two of the ridges here. They're both on the west facing roofs. Another thing that we have overhead, we have some LED lights manufactured by a company that unfortunately is no longer in business. But the cool thing about this technology is that you can see over here on this side of the greenhouse, the lights are on, and on this side of the greenhouse, the lights are not on. And the reason for that is that they have an algorithm with a sensor that measures the amount of light that the plants are getting, and considering how much light they're getting naturally versus what our target light level is, they'll turn on and off depending upon what time of the day it is, how much sun they've gotten, and it can figure out how many more hours of sunlight there is available for natural lighting and how much light they need to add to hit our desired set points. Okay, so that's a really nice, I mean, LED lights are getting more and more popular, but ones that have the ability to be smart is a really nice advantage for us. We also have some LED lights that are two-sided that go between the canopy of the cucumbers. They're not on right now because we're getting plenty of sunlight, but they can also be turned on and off based on the amount of light that we're getting. So that's another nice feature. The cucumbers have shown to have a very large increase in growth when subjected to intercanopy lights of red and blue. Okay. Another piece of technology that's in this greenhouse is this, we're using grow slabs of growed animals, rock wool, and this little grow sense is a tool that measures the electrical conductivity and the pH of the slab. And if I can get this around out here. So there's the titanium sensors that slide right into this slab like so. And we have a little handheld meter that we can read, and it can download almost a month's worth of data to see how the block is responding, how much salts it's accumulating, and how much the pH is changing over time. Okay, so that's another nice little piece of technology that allows us to monitor the root zone of the crop. Obviously, the environmental computer and the greenhouse environmental computer can give us a lot of data as well. We also use these ones that are called a watchdog, and these measure the amount of light that's coming into the greenhouse that we can then compare with the LumiGrow light. And this one also measures the temperature and the humidity. And it's a really easy one to look at when we're online. We can see exactly what's going on from day to day, or really from hour to hour. So it's a really nice thing, again, to help you quickly monitor your environmental conditions. So this greenhouse has been designed really to grow crops that we consider to be high wire crops. And you can see there's wires that are going up that will help hold these cucumbers up as they get taller and taller. The other final piece of the technology that's going into this greenhouse is a high pressure fogger. This is a high pressure fogging system, and I'm just about ready to get it running. I've got almost everything I need. I had to get a booster pump because it needs to have a minimum of 45 PSI just to turn on, and then it runs on 40 to 45 PSI. So that's the greenhouse. We also have, well, obviously there's a lot of cool little switches and things like that. And this is the environmental computer that's running our greenhouse. And I got the fan, I got this open because I turned the fans off so I could hear and you could hear me. The other thing about this greenhouse is pretty nice is that there's these drains, there's 4 drains, and they all run into an underground cistern. And that underground cistern then is connected to a slow sand filter, which is, well, not quite ready to work yet, but it's getting closer. And the function of that is to get rid of all the bad microbes, all the soil-borne pests that we might find. So anyway, that's the AgTech greenhouse. So this is the Carrillo Horticulture Substrate Strawberry area. We're growing over 600 plants in these troughs. And these troughs are filled up with cocoa fiber and perlite. The strawberries are starting to flower, which is good. We'll have some fruit. The idea behind using substrate is that we can tailor our fertility very, very closely and to what they would really like to be. And it's super easy to harvest. I'm standing up. So a couple of things, technology here that's helping us grow these crops. This is an ET evapotranspiration meter, and it measures, this is a simulated area of vegetation and soil, and you have filled up with water. And when it evaporates out, then the water level drops, and you can tell how much water is evaporating in any given period of time. And then you can trigger an irrigation event based on what your ET levels are. The other sensor here is a solar cell, and it's connected to another type of irrigation controller. It's called it's called a solar accumulator. And the solar accumulator counts how much solar radiation is coming in, and you can adjust the irrigation based on solar as well. So that takes into account, the heat of a summer day versus a rainy day in the fall. If you're using a timer, you really don't have any flexibility. Another piece of technology that we're using here, this is a sensor for measuring water and electrical conductivity, and it's placed into the media, and it tells us the water content of the media. This is another sensor, but it's a little bit different. It doesn't have the EC portion to it, but it's a COM Spectrum Water Scout, and it's measuring the volumetric water. The weight of the water is the weight of the soil, and that is going back to our Spectrum equipment that I've showed you in the AgTech greenhouse. And I'm going to show you, I'm going to hop over this barrier here, and I'm going to show you the solar accumulator controller. It doesn't really look that fascinating, but I'll give you a shot of strawberries. So the solar accumulator is a piece of equipment built by a gentleman out of California. And it basically what it does is you can see, you can measure the amount of light in lots of different units. And then you can say how many seconds or how many minutes you need before you need an irrigation event. So you set the amount of solar count based on what you think you need to water your plants. And you can miss them, or you can irrigate them, or you can do both. For us, we're going to be irrigating, but we're going to irrigate with the mist setting, so we can only have to water 30 seconds at a time. Okay, so that's the solar accumulator. The alternative is nothing more than a irrigation timer for outside, which doesn't take into account changes in the weather from one day to the next. So that's a bit of these timers work okay indoors if you're growing exclusively in a combined environment. But if you're relying on greenhouses and outside, the conditions change hourly, and you need to be on top of that. Right, so this is our aquaponics system. Right, this is in a different greenhouse. This is in a hydroponic greenhouse. Fish are getting excited, it's getting close to eating time. This is set up with 4 fish tanks and a solid separation, a mineralization tank, a degassing tank, and then the water, after it's been somewhat cleaned, gets delivered to the grow beds, which there's 2 of them. There's 2 40-foot long by 4-foot wide rafts. Systems here are designed to be floating on 10 inches of water or thereabouts. And the plants are sitting in the water, completely submerged in water. This is a deep raft system of hydroponics that uses fish waste for plant nutrition. A nice system, kind of hard to get settled in, get them started. It takes this type of system usually takes about 6 months or longer to get the system to reach some sort of an equilibrium. It's very dependent on the amount of fish food that you add. You have automatic feeders. Automatic feeders are adjustable by how long they vibrate and how hard they vibrate, and the time in between those feeding events. So the koi, medium koi, koi are nice. They all have names. They're all named Bob and Koi. So they grow really fast. So we monitor, we keep the system balanced by keeping track of how much food they get, and also by removal of the solids. And you probably have had fish before. This is a solid removal system here where we have the solids are floating and we try to trap them. Then it goes into this mineralization tank where the microbes break all those soluble solids out into the nutrients that the plant needs. Okay? So you can balance the load by the fish food and the amount of plants we have. So fewer plants, we have fewer fish and less fish food. Next system we have is an empty nutrient film technique table setup. This has been shut down temporarily because we had a disease problem. And so we shut it down and cleaned it up. Everything's all clean, ready to go. We have a system that will monitor the environmental parameters of the water as well as dose individual concentrates as needed. So we have fertilizers that we make up, and we have probes, pH probes, EC probes, like so, measuring all the water parameters. Okay, so this one will be up and running in a few days. In the meantime, we're running some things over in a different system. We have multiple systems here. We also have some floating, these are ebb and flood benches, whereby we're irrigating a couple of times a day with a certain amount of moisture. This one happens to be doing it right now. You see the water's coming in, and what will happen is it'll stay on until the timer says it's time, and then it'll click off. But we'll get enough water in here to get these plants watered properly. So it's an automatic watering system. Okay, again, here's some more things on those same types of benches. Here's some more. These are bedding plants, alyssum and zinnias that we'll sell at the farmer's market. These are some beautiful little 4-inch quart sunflowers. And here's our first sunflower crop of the year. This is a taller one. Considered used to the market as well. Here's another. We actually have 3 NFT systems. This is system number 3. This is system number 2. So this is basil. It's got basil growing essentially in water, little thin film of water running along from the top. Here's the flow of water. You can see there's not a lot of water, right? And that's how much water the plant gets all day long. Got watercress as well. And again, here's the system that we use to monitor the pH, the electrical conductivity, the water temperature, and also adjust all of the dosing that can be done. We also have a silly little backyard aquaponic system that a student put together a couple years ago. Got some one koi, goldfish. This is a system that just runs continuously, and these hydrogen balls are the medium in which all the mineralization from the fish waste gets deposited. So that's pretty much it for this greenhouse. We have LED lights for the same company, Lugrow, for increasing our growth in the winter times. And they're kind of silly sometimes. Sometimes they don't know they're supposed to be off. They make some kind of cool little slideshow or a little light show. I'm not really sure why they're doing that, but that's what they do. All right, so that's about it for this. So this is a vertical farm designed really. The intent was to grow microgreens and some root style crops in here. We found out quite quickly that it's a really difficult thing to manage with students because they.
Right now, he's in that little box, that little house that was inside one of the greenhouses that Sarah showed us a picture of.
Yeah, really, really fast, and it's hard to get the students to be around that frequently. So I have converted this into mushroom growing room, and the mushrooms I'm growing right now are called cordyceps, and they look like Cheetos when they're fully grown. Some of these are kind of starting to pin a little bit. back there, you can see the color's pretty wanky in here, so it's pretty hard to see. Anyway, so that's the vertical farm. It's designed for microgreens and such. Again, controller right here. This is a auto grow as well as the dosers that I showed you before. And this one controls the lights, controls CO2, it controls the pH and the EC. It's web-based, so I can go online and look at all the data. I can set things. It has air conditioning, it has heating, humidity control. So it's a pretty nice system for small rooms, but they also have a nice system for larger gardens. Okay, so that's it.
Okay, I don't know what's happening right now. Didn't it sound like that was the end of the video? Because he said that's it. I'm wondering if it's still taping by accident, but let's just watch it for a little bit. I'll put the speed on a little faster. Hang on a second. I got to move our photos again. Okay, let's just see what happens. I'm going to move it forward a little bit. Okay, I'm going to stop. I'm going to stop sharing for a moment. Okay, what's your guess? I'm thinking that it was over and we were just watching him do some plant science stuff. You guys
looks like he finished with the main part.
What was that, Adam?
It looks like he finished with the main part of his video.
I'm sorry, you're cutting in and out, so I can't hear you. Maybe put it in the chat. Yeah. Yeah, I'm just going to make the assumption that the video is over, okay? Is everybody all right with that?
That's fine, Joanne. Thank you.
Okay, so I think between Sarah and, I mean, Peter's talk is showing you exactly how technology and engineering is in plant growing, and we have it up at the Horticulture Center. He mentioned a few times the farmer's market. He and horticulture students sell their crops at the farmer's market that's at Cabrillo on Saturday mornings. So they sell their stuff and it's really great things and it's pretty inexpensive too. So if you want to go there, certainly you could get a tour of the horticulture. We could do that once we're back in person, you know, next year. But I think that's, it's really neat to see what we actually have done, growing there and actually the technology that's being used. And then Sarah talked about the different, you know, career paths that you could have in ag tech. All right, so now I'm going to go back to our slides and share our slides. So I'm going to go back to the beginning. Okay, so first we heard from Sarah and then we got a tour from Peter. And the next thing is I'm going to show you some ag engineering career paths. So I'm going to minimize this. And hang on a second. Okay, do you all see now a PowerPoint slides that say discovering agricultural engineering?
Not yet. I think it's loading.
Okay, so hang on a second. Let me stop sharing and then share something else. Okay, do you see it now? It says it's orange and it says
Yes.
discovering.
Yes.
Yes.
And now I'm going to make it bigger. Do you still see it? Yes?
Yeah.
Okay. All right. Okay, so this was put together by Keenan Roop, who's a Cabrillo alum. And he decided that he just loved agricultural engineering and he wanted to put a PowerPoint slides together for us to use as faculty in Engineering 5. So, you know, and you could read through this as well. You know, agricultural engineers are tackling the big puzzle in our world about producing enough food for people and with the environmental, being conscious of the environment, which Sarah mentioned already. In operations, some agricultural engineers are more like mechanical engineers where they're designing machinery, the whole operation of it, which also includes industrial engineers. And later on, Katie Griffin is going to speak, and she's an industrial engineer who actually worked in ag for a while. Sarah talked about harvesting equipment, and that's what we see right here. And then Keenan also wanted to mention that, you know, ag engineering is also about irrigation and water systems. And this is a picture of the California aqueduct. And in terms of water use, not only the use of water, but also you probably have heard that we've had some issues with saltwater intrusion, which means the water, salt water from the ocean is coming into the groundwater. And that's a big issue in Watsonville now that they're dealing with. So you could see that agricultural engineers are also dealing with water. This one was interesting. Some engineers are designing these large structures that can hold crops. And it's similar to a train of 70 cars filled with coal. So I thought that was pretty interesting because you can't really tell the scale of this from a picture. And then there's a lot of surveying. One of the classes we teach in engineering is surveying. And you would know that it's definitely for civil engineers and environmental engineers, but it's a big part of agricultural engineering too, because you really have to understand the lay of the land. And even though this fall is still going to be online, the surveying class is going to be, the field part of it is going to be taught in person. So those of you who are interested in civil engineering, surveying is a class you'll be taking. And those of you who have met with me already, I scheduled you for taking surveying. And then also agricultural engineering is also about air and water quality, which makes sense because in order to grow, you need to assess what water and air is around. And then Sarah mentioned this about some ag engineers work in labs, and this is similar to any engineering field that you might be working in the small scale in labs, or you might be working in big scale. And then at Cal Poly combines their agricultural engineering with bioresource engineering. And it's really combining everything, agriculture, water, biological engineering is what Davis has ag engineering and biological engineering together. But all three of them are together. It involves biology, it involves engineering, it involves ag, water, all that together. And then this is a picture of one of our horticulture students, the aquaponics, which you saw the video from Peter. And then also, this is another interesting project. I'm sure you've heard about people who are running their cars on biofuels, right? Restaurants are using, you cook with vegetable oil, and then the vegetable oil that's done, like after you get your French fries that taste so good, that oil gets scrapped after a certain while, and then you could use that vegetable for modification. And that's what this is all about, engine modification. There's an engine right here. And certainly that's a renewable fuel, right? We're always going to be making French fries and fried foods. American Society for Agricultural and Biological Engineering, I already gave you that link. And then these are some sources that he put together for his PowerPoint. So you could look at that if you're interested. So I'm going to stop this for a moment. And I'm going to go back to our module just to show you where we are. So these are the slides. This is Peter's video. This is Kenon's slides. And now I'm going to go on to Katie's talk. Okay. All right. So I'm going to pull this up and I'm going to open this. Can everybody see this video starting?
Yes.
Luis and Angel? Okay, great. Okay, and I'm going to keep this at regular speed. And then after this, we'll take a break. Okay, so we're going to get through this first. Hey, Katie. Thanks
Hi.
so much for coming to speak to Engineering 5 today. I really, really, really appreciate it.
Happy to be here.
So Katie, I know you're an industrial engineer. So why don't you first talk about what industrial engineering is?
Okay, so my favorite industrial engineering saying is that engineers make things and industrial engineers make things better. So that kind of sums it all up. We look at the whole system, the whole process, what's coming in, what's going out, who are the suppliers, what equipment is needed, and try and really optimize that holistic system. A good example of something that you might have interacted with that you didn't read.
Hey, I'm going to stop it for a minute. I realized that I wanted to show this later when we're doing industrial engineering. I didn't want to show this now during ag, even though she did industrial engineering and ag. So I'm going to put this off till later. Okay. I want to finish the ag piece first. So let me go back to here and I'm going to go back to our, not that, not this. Where are my slides? Ah, here it is. Sorry about that, you guys. All right, I have to move our pictures again. Okay, so Sarah, have Peter talk, and then Kenon, and now I want to talk to you a little bit about the Engineering Abroad program, and then we'll take our break. Okay, can everyone see this slide that says Engineering Abroad on the bottom? Everybody sees it? Okay, I need to move things out of the way again. All right, so we've had the Engineering Abroad program now around for 8 years. My intent, and the reason that I'm talking about it is because it's all related to ag and water. The reason that I started an Engineering Abroad program is because I feel like when I've traveled, I've learned so much about people and it's shaped who I am. And I'm also a real proponent of engineering being a helping profession. And in a way, this abroad program provides both. One, you get to travel, work with people in a different area, designing and building engineering projects. And you're really showing that engineering is a helping profession because you're helping communities, helping people, and also helping the environment. So the first few years of our abroad program, we went to Guatemala. And our trips, when we go on the abroad experience, are always in January. So we meet, it's a year, the abroad program is a year-long program. In the fall, we meet with students every week in a course, and we prepare for the abroad experience where we learn about the culture of the country we're going to. We learn about how to be safe in a third world country, because often drinking water can make you sick. And then the third thing is we learn about the projects we're going to work on, and we start preliminary design. So that's what we do in the fall. And then January, we go on the experience. And then in the spring, we come back and reflect and do a lot of presentations to start meeting engineers so we could get internships and get better at presenting. This particular year, because we're in the pandemic, the abroad program couldn't go in January, we're going in the summer instead. So the first few years we did projects in Guatemala, and the last couple of years we've done projects in Costa Rica. And I just want to give you an idea of what those are about. There are a couple of videos you could watch if you'd like to learn more about it. This is a top view, a bird's eye view of the community in Guatemala we worked with. And we did a number of projects. One is we regraded a soccer field that was starting to slope down a hill, and that's all great now. We built a computer lab, we built a retaining wall, but most of our projects, the circles, have all been about water. In Guatemala, there's a ton of water in one season, and then it's completely dry for the next season, and people run out of water and they have to go get water. And in the villages, it's the young girls that have to go get water. So a lot of girls are not in school. When we started the abroad program, the only water storage capacity the village had was 500 gallons. And then during our number of years working in Guatemala and putting in more water tanks, and then some other groups came in, they now have a storage capacity of over 19,000 gallons. And all the tanks are these little blue circles all around the area, because this town is all a hillside town. They're all built on a hillside, and there's about 120 families, and each family has about 10 people living there. So now what's happened, which we never even knew would result from our project, is there are more than 50% of the kids in school now are girls, because they don't have to go get the water. So this wasn't an ag project, but it was a biological engineering project, because it was all about providing water. Julio, you need to mute yourself, sorry. Or I guess I could, yeah, good. Okay, then going to the Costa Rica. So this was about 5 years of projects, and this is 3 years. In Costa Rica, the community we're working with are almost all of them coffee farmers, and they were growing coffee in the traditional way with pesticides, and they were realizing that the pesticides was ruining their clean river, which was the water source for the community. So they started moving to organic farming, but the holdup in having more of the community turn to organic farming is they didn't have enough compost. So we went in, and our first project was to design and build a shredder, kind of like a paper shredder, but it's more immense. This is all steel in here, steel things to grind all the plants in the field, so that we could shred them so that they could become compost sooner. And the other project we did is we introduced rabbits. The rabbits would poop. Rabbit poop, just like the fish poop is helpful for agriculture, so is rabbit poop. And these are the compost bins. So we set up we built rabbit hutches over the bins, and the poop would drop in. So between the poop and shredding the material, they were getting more compost, and more families can convert to organic farming for coffee, and for others too. And then the project that we did last year was we work with this fish farmer. In this case, what's the I'm not remembering the fish. Sorry about that. But there are a number of fish farmers, and fish is a staple diet in Costa Rica. The only problem is every so often when he had to get rid of the water, because there would be so much poop down here, the water would just spill into the river and contaminate the river. So what our engineering students did with the community is they built something called a bioswale. They basically made this huge filter. So I believe that the elevation here down to the river is 100 feet. So they built this swale with all rocks. So what happens is when the poopy water goes down here, it goes into the swale and it gets all filtered out. So by the time the water gets to the river, it's only water and it's not poopy water anymore. Okay. So we have had agriculture-based projects with our engineering students being able to go abroad. And like I said, there are 2 videos here, In the spring sometime, probably in May, we'll have an application. So if you're interested in applying for the abroad program for next year, you can apply, but the application process isn't open yet. I'll let you know when, and it'll be posted to the engineering student Canvas page. And students come back from this abroad experience really feeling empowered that they know how to build things. They know how to relate things they learned in school to real life. And they actually made an impact on a community and helped a community and got to travel at the same time. Okay, I'm gonna get this down. And then the last thing I wanted to mention was about Cal Poly and UC Davis. They're the two programs in California that have ag programs. So I'm going to stop sharing for now. And let me just give you a breather for a minute and make sure that I showed everything I wanted to show. Yeah. Okay. So I'm at a point. Emily. Hey, Graham, you must be on Emily's, our speaker Graham is going to be coming on soon. And it looks like he might be a little early. I don't know, some of you know, but I'm actually visiting my 85-year-old mom, and I took her for a second shot in New York. So I'm actually 3 hours ahead of you. So it's kind of a balancing act to, let's see, that 3:45. Yeah, we're doing good. We have time for a 10-minute break. So if you guys would like to take a break and come back in 10 minutes. So for you, that would be 12:45. Okay, so I'll see you in 10 minutes. Come back at 12:45, and I'll write
Okay.
that in the chat too. Return at 12:45 p.m. Great. So Graham, I see you're here.
Hi, Joanne. How are you?
Okay, how are you?
I like your technical verbiage there.
You like the poopy water?
Yeah, I got a good kick out of that.
Okay, great. So we just watched a video of the horticulture program, a tour up there about doing aquaponics and using poop from fish to grow plants. And then I was just showing them something else. So the beginning part of this class is all about ag engineering and biological engineering. And now when we come back from the break, that's when you'll start talking about, well, actually, hang on a second. You're coming on at 1:30, is that right, Graham?
Yeah, I had seen a few things in the email, so I don't have much to do, so I'm just kind of logged in, listening and getting
Okay,
a feel
great.
for the class. But yeah, I'll be here. I'm kind of working in the background, so
Great.
just let me know and I'll turn my video on and take over.
Okay, sounds great. Because I would like to show them a video of industrial engineering first and then show them a short presentation by one of our students who is an industrial engineer but worked in ag. So kind of like a segue from the ag to industrial.
Okay,
All right, does that sound okay?
absolutely. Just let me know. I'll be here
Okay, great.
whenever.
Okay,
Thanks.
awesome.
Okay.
So I think I'm going to take a break for the next 10 minutes too. I'll be back in a little bit.
Okay, do that.
Okay, great.
Okay, bye-bye.
Yeah.
Take exit 480.
Hey, everyone.
Hi, I'm Phil. It's hard to make a good impression on video, which is why we made, it's like instant weekend update. Industrial and
Okay, everybody, you ready? We're back now. Okay, so so Graham Farmer, who's an industrial engineer who's here to speak with us, he's gonna come on in a little bit. So right now I'm gonna just go back, I'm gonna share the screen and go back to where we are on. So I first hope that, you know, the information that I'm exposing you to with agricultural engineering is helpful. And some of you might find an interest in that. Okay, now I'm going back to the PowerPoint slides of, we're looking at industrial and manufacturing engineering now. And again, I listed the two technical societies for both. And the first thing we're going to do is watch a video about, just get an overview of industrial engineering. Then we'll watch the video by Katie, and then we'll talk to Graham. So let's make sure that, can everybody see a screen now that is a YouTube video that says industrial on the top?
Yeah.
Yes? Okay, great. Okay.
engineering is a branch of engineering that focuses on making processes better. It's a lot of optimization and making those processes more efficient. So let's just go into applications and see what this even means. And let's start simple. Let's say when you wake up in the morning, your routine is you go from your room to the bathroom to shower, then back to your room to change into clothes, then downstairs to eat, then out the door to work or school or whatever. An industrial engineer would look at that process and say, what if instead you went from your room and took your clothes with you to the bathroom, showered, then changed in there instead of going back to your room, then you went downstairs to eat and leave for school or work. You just eliminated the need to go back to your room after the shower and therefore improved the process and made it more efficient. In this case, you improve time and distance you have to travel. This example is simple, but clearly not a career path. So now let's see something more applicable. How can we make going through a line more efficient? At a bank, for example, everyone waits in one line normally. Then you go to whichever teller is available once you're at the front. This is nice because if one customer is taking a while, the people in line will still get to choose from the other tellers as they open, which keeps the line moving. So is this the most efficient? What if they set it up like a grocery store instead? At a grocery store, there are maybe 5 cashiers open and people choose one line to wait in. Could you imagine something like Costco with one line that then goes to multiple cashiers at the front like a bank? Due to the amount of customers, the line would look insanely long and would probably cause a lot of people not to shop there. Therefore not efficient because it's not good for business. So grocery stores and similar places probably have the right idea. But is the bank?
And let me just cut in for a moment. I don't think I mentioned this to you, but have you been downtown Santa Cruz at Pizza My Heart? The line is out the door always. It's totally inefficient. Every time I walk past there, my stomach starts to turn because I think, not for the food, but because it's just so irritating to me. So I actually spoke to the owner, Chris of Pizza My Heart, and James, who you're going to watch the video, one of my past students, James, who you're going to see a video of. He and I are going to work with a group of students and design a more efficient way to get customers in and out, except this crazy line, instead of this crazy line. So I'm really excited about that. Anyway, okay, I'll keep talking. I'll let the video go.
Bank wrong? Well, probably not. It depends on factors like the amount of customers coming in over a given time interval and the speed to which they are helped and so on. Banks often have shorter lines and less people per hour, so one line for them is probably the best way to go. All these factors are what industrial engineers need to analyze. But now let's look at something like Disney World. Places like this are huge on hiring industrial engineers. Industrial engineers analyze data about lots of aspects of the park to improve wait times for entrance, rides, food, and so on. These parks use techniques to track how long it takes someone to get through a line. Industrial engineers then take this data and figure out ways to improve how the line will move to improve people's experience. Industrial engineers will see data like the average attendance on each day of the week. If it's a low number, then maybe they can change the structure of the line. Some lines you may see weave in and out a lot if it's crowded to make it appear shorter. With new rides and attractions constantly being added, then varying attendance for different days of the week and times of the year, more data samples always being taken, industrial engineers could have very consistent work at places like Disneyland, Disney World, Six Flags, Legoland, and various other theme parks. A project you could see in class, which is also a career path, would be looking at something like Amazon. Let's say Amazon is going to build another warehouse that is going to receive, let's say, 10 million products per week that it will eventually ship out to people. So it might receive 5,000 orders of product A, 15,000 of product B, 100,000 of product C, and so on per week. The problem is, how should everything in that warehouse be designed to make the process of receiving and shipping products the most efficient? How are the trucks going to drop off the products? Should they use forklifts to take the products out of the trucks in pallets, or use more people to unload directly from the truck? What's the time it would take for each? Where should all the products in the warehouse be placed? Well, let's say if product A and product C are getting the most orders and ship out at the same time, put them closer to the door so people can load the truck quicker. Maybe put the least ordered product furthest from the door. But what if it's also the heaviest and takes the longest to move? Will that be worth it time-wise based on the orders it receives? These processes can clearly get complicated. Then a huge career path for industrial engineers would be to help improve and manage the manufacturing process of really anything. Manufacturing applies to nearly every product: airplane parts, rocket parts, car parts, household appliances, windows, doors, game consoles, candy bars, soda and bottled water, and so on.
Grammarly does.
Oh, right. Remember they do this? They give these little, okay, so I'm just going to play it and we'll have to skip it.
More than
Sorry.
catch errors. With Grammarly, you can find really good, no, perfect words.
Now, manufacturing plants are normally a lot of people, each with their own station, and often conveyor belts that move the product through the plant to the people so they can do what they need to until the product is complete. Now, you will not be one of those people with their own station as an industrial engineer. Those are the operators. You will look at the entire process as a whole, manage it, and figure out ways of how to make it better. So let's go really simple. Let's say a plant has 2 workers to manufacture paper clips, and let's say there's only 2 steps. The first worker at station A makes the straight piece of steel wire, which takes 2 minutes. Then it's handed off to the second worker at station B, who uses a machine and bends it into the paperclip shape, which takes 4 minutes. An industrial engineer comes in to review the process and sees that the second worker will have a pileup of steel wires to shape because he's finishing his process twice as slow as the first worker. So the engineer says we should add a worker to station B, so that way it takes 2 minutes to make the steel wire and 2 minutes on average to shape one. Everything flows smoothly and in the same time interval, which means faster shipments and more money. But what if we had 10 workers at station A and 20 at station B? Now we can make 10 times more paper clips to ship off, and that's even better, right? But we also have to pay 10 times more people. Is it worth it based on how much money the extra paper clips make versus the worker's salary? Are those extra paper clips even being sold that quickly, or have we exceeded the workers we need for maximum profit? What if there was like 6 stations like in the real world? and each person took a different amount of time to finish their respective job. How would we ensure minimum pileup of work or time waiting around? Are you seeing why industrial engineers are so important? Optimizing time and even profit is what industrial engineers need to do. A senior project a group of students did was to look at a manufacturing company that made buses. The company was able to make 300 buses per year, but they wanted to make 325 without adding more people or buying more machines. The industrial engineering team looked at the process, saw that the bus had to go all the way around the factory in a spiral-like square to all these different stations, like for putting on the engine, the tires, the windows, etc. Then also people at certain stations needed to communicate very often with people at another station that was far away. The industrial engineers thought of how to move the stations around, so the bus had to move a much shorter distance, then also so workers that needed to communicate with each other would be closer together. This may not seem too complicated, but I had to simplify it for the sake of this video's length. But this kind of analysis could apply to any manufacturing process, from paper clips to buses to fighter jets. Industrial engineers could optimize the distance nurses have to travel to deliver a blood sample to a lab in a hospital, or timing of airplane arrivals and departures at an airport so there isn't a long wait time for the plane and its passengers. Really just any process. Industrial engineering is often not high-level math, physics, chem, or anything like that. I don't want to say it never is, but it often is not. It's often looking at statistical data and coming up with solutions through testing or simulation. Industrial engineers will watch the process as it happens, maybe even take a stopwatch and time how long different processes take, collect the data, then they take that time of different processes, the cost of materials, the amount of products that need to be made on a given day, the distances that these objects travel, and come up with ways to make the process better. Note that some of these jobs are things you don't think about. Most people probably don't think Disney World lines are being continuously analyzed and optimized, or that Amazon needs to put that much thought into its warehouse layout. But these jobs do exist because all companies want to cut time and costs, and need to make sure everything gets done on time. Industrial engineers look at the efficiency of processes, but also the cost of materials, the forecasting of future materials needed, making sure everything arrives on time and in the right quantities, that all the machines are working, and so on. They improve, but also manage the process. Also note, industrial engineers don't really do the design work. If you want to make lasers, design radar tracking systems, design spacecrafts that can travel faster, design military aircrafts, build synthetic body parts, and so on, industrial engineering probably is not the best for you. Industrial engineers eventually often go into manager positions where they manage people and work their way up in the company, rather than stay and continue optimizing and overseeing types of processes, but of course that is up to you. But if you like looking at the business side of things and increasing profits, optimizing the time to finish something, managing shipment orders, quantities and pricing, statistics, and working with or managing people, then industrial engineering may be good for you.
Okay.
I signed up to be a dasher and I absolutely love it. The
Hang
sign-up
on a
process is
second.
super easy, and there's opportunities in 4,000 cities. It's so fun and such an easy way to make cash.
Okay. Okay, so you could see that industrial engineering is all about organization, right? So those of you who love making things organized, industrial engineering may be the field for you. If you're not that one who's that intrigued about things that are organized, then maybe industrial engineering isn't for you. But let's watch Katie's presentation now. And can you see Katie's presentation or no?
No.
No? Okay. Okay, do you see Katie now?
Yes.
Yeah.
Okay, great. Okay,
Realize was,
let me just back up a little bit.
and industrial engineers make things better. So that kind of sums it all up. We look at the whole system, the whole process, what's coming in, what's going out, who are the suppliers, what equipment is needed, and try and really optimize that holistic system. A good example of something that you might have interacted with that you didn't realize was an industrial engineering thing is like going to Starbucks, right? You can go to Starbucks in Santa Cruz, in San Francisco, in Australia. And that cup of coffee is going to taste the same no matter where you are, because there's a ton of industrial engineers working at Starbucks, making sure that how they make their coffee is standardized. And that's a very typical industrial engineering activity. And what else can I say about industrial engineering? So it started out as industrial engineering, meaning that we worked in factories and we worked in manufacturing. But today, industrial engineering is in every industry you could possibly think of. So we work in hospitality, we work at hospitals, we work at amusement parks. Disney hires a ton of industrial engineers to optimize how guests come in and out of the park and how they get on and off rides and all that kind of stuff. Of course, we still work in traditional manufacturing environments, whether you're making a car or a soda or a toilet, roll of toilet paper, right? Like all kinds of manufacturing. We also work in agriculture, which I have some experience in, but just about any industry you can think of can benefit from hiring industrial engineers, because we're process focused and everything is a process, right? No matter what you're doing, there's a process involved. And the other thing about industrial engineering is there's a lot of sub-disciplines. So for me in particular, my focus is, and my specialty is process improvement or lean manufacturing. But a lot of industrial engineers find themselves working and specializing in things like ergonomics, which is how does the physical body fit within the workspace? A lot of industrial engineers will go into quality fields or reliability engineering. That's a huge sub-discipline for us. Human factors, operations research and optimization is another really critical field. Supply chain management, you'll find a lot of industrial engineers there. So even within the umbrella of industrial engineering, there's a lot of sub-disciplines and focus areas that you can choose.
Thanks for giving us the overview.
Yeah.
Okay, so now what I want you to talk about is your educational path. Start with high school and then your transition through Cabrillo. And then I know you went to San Jose State. So talk about that, like where you grew up, which high school you went to, why you came to Cabrillo, why you chose the major you did, or when did you know you wanted to go into that major? Why did you choose San Jose State? And then your experience at both schools. Thanks. I wanted to put it on pause again. The background that I have on this video is my office. So a couple of weeks ago, I went into my office, which I was very happy to be in. And a lot of these pictures have to do with past students that are doing really cool things now. And all the shirts up here all represent conferences that we've gone and the engineering abroad. So anyway, you're getting to see what my office looks like. Okay.
Oh, sure. So I grew up here in Santa Cruz and I went to Santa Cruz High School. I graduated in 1999. When I was leaving high school, I had no idea what I wanted to do for my career. I didn't know if I wanted to go to school. It was just kind of, not a clear path forward. And I found myself at Cabrillo. Probably my second semester at Cabrillo, I signed up for the Intro to Engineering class, Engineering 5, with Joanne as my teacher. And I did that because my older sister had kind of made an offhanded comment about, this engineering career, and I knew nothing about it, but I knew that if you're good at math, you might be a good engineer. And I always really liked math from, even middle school. And so I found myself in Joanne's class, and in that class learned all about what an industrial engineer does and a mechanical engineer and an electrical engineer. And it was really clear to me by the end of that semester that I had found my career path. And I think we did an assignment in Engineering 5 where somehow I found out that my grandfather was also an industrial engineer. So it was like in my DNA to go down this path. But I also at the time was working for a construction company, and I really liked working there and thought maybe I would consider civil engineering. So while at Cabrillo, I took the surveying class and kind of, suss that out, but just felt after that semester that, maybe civil engineering wasn't quite for me. And I really, really was attracted to the industrial engineering field. So I was at Cabrillo for a long time, like 6 years, I think, 2000 to 2006, if I remember correctly, because I worked, the whole time I was there. I would go to school maybe 2 days a week and work 3 days a week, and then work in the summer because I was supporting myself there at Cabrillo, and just kind of had to stretch the whole process out a few years to get it done. And then I didn't want to move away when I was kind of ready to transfer to that upper division coursework. I wanted to stay living in Santa Cruz. And that was a big reason why I chose San Jose State. It was also affordable. There was a transfer agreement in place. So I knew that, with Joanne's help, kind of figuring out what classes I needed, that transfer process would be pretty seamless. So to me, it was they were like my number one choice school, and, going there just worked out really well for me because I could stay here and commute on the Highway 17 express bus over to San Jose State, which Joanne also told me about and gave me that tip. Which I hope they're still running, because it is an incredible resource, because you can sleep on the bus, you can do homework on the bus, you can eat on the bus, all the things that you can't do while you're driving. So you can get a lot more done in the day. So yeah, I went from Cabrillo to San Jose State, and I was able to get some scholarships when I made that transition. And so I went to San Jose State full time and did not have to work the way I did at Cabrillo, which was a huge, relief for me to just be able to focus and take like 5 or 6 classes a semester and really focus. And I loved being at Cabrillo or at San Jose State because I was fully immersed in the engineering curriculum, and I just, it reinforced what my choice. Like, I loved all my classes. I loved the material that I was learning, the projects that we were doing. It really solidified once I got there to that upper division coursework that I had made the right choice. And one thing that I will say about that Cabrillo San Jose State transition that I sort of maybe messed up on a little bit is that when I applied for graduation at San Jose State after 2 years, I had to go a whole nother semester because I had failed to meet some of the GE requirements. And so I ended up in my last semester at San Jose State taking like a PE class and a philosophy class and no engineering classes. So students, make sure you check your GE recs before you leave Cabrillo. Otherwise, you might end up there an extra semester more than you planned. And of course, tuition at Cabrillo is so much more affordable than at the state school. So get as many classes done at Cabrillo as you can. And let's see, while at San Jose State, my first year, I did a summer internship with Driscoll's out in Watsonville. And that was kind of my first exposure to using industrial engineering in the agriculture industry, which I loved. I spent the summer working at their produce cooler and doing time studies on some of their warehouse processes. So that's me going out with, a stopwatch and a clipboard and keeping track of all the steps in the process and how long each step takes and where we might eliminate steps or make a step faster. And that was really great. That was a fun internship. I learned about Driscoll's and I learned about the produce industry. And then I went back to school for my last year and then ended up getting a second summer internship. And that internship I got through a connection with one of my professors at San Jose State. So that's another tip for you students. Get to know your professors, make those connections. You're going to need that network, both when you're in school, but also when you graduate and you're ready to start looking for work. And you're coming from Cabrillo, which is an environment where the teachers are so accessible and open door policy, come and talk to me during office hours, right? It's not always the case when you get to the bigger schools, but you need to assert yourself and you need to establish those relationships with your teachers because they will get you jobs. At least that was my experience. So that's tip number 2 for you guys. and also just take advantage of those summer internships, because you get to, experience different companies and different types of projects. And so my 2 internships were completely different. One was doing, traditional time study, industrial engineering, process observation work in agriculture. And then the second one was doing modeling and simulation work focused on the air traffic management research industry. So completely different. And that last summer internship that I had at the airport modeling and simulation company, I ended up going to work for them full time when I graduated. And that was in the fall of 2008. So December 2008 is when I graduated out of San Jose State. And then I worked at, it was called Census back then. I worked there for about 6 years and built a lot of computer simulation models, did a lot of data analysis on, airport traffic flow, planes taking off and departing from the airports. I did quite a bit of project management work in that position, which is another thing that IEs kind of naturally, I think, fall into, because we're typically very organized. It's easy for us to kind of see the big picture, to plan out a project and then, check progress and milestones against that plan and kind of hold people accountable. So I did quite a bit of project management work in that position. And then in 2014, I got an invitation to attend a talk at San Jose State, where a gentleman came and talked about applying industrial engineering in the consumable food industry. And my heart started beating, because ultimately that was my dream job. I wanted to go work at Dreyer's Ice Cream and do process improvement in an ice cream manufacturing facility, or, a chip manufacturing or cookie manufacturing company like Kellogg's, or, something like that. But I just always assumed that I had to move to the Midwest to get a job like that. And so I met a man by the name of Caleb Mabrook, and he had a really small consulting firm. And I just went up to him after the talk and I was like, I want to do what you do. How do I, get involved in your company? And he handed me his business card and it showed Santa Cruz as the address. And I just was like, oh my gosh, it was meant to be. And so he hired me on as employee number 2. And it was him and I for a long time. And eventually we hired some additional engineers, and we had just a really small, boutique consulting firm. And a big focus for us was bringing industrial engineering, bringing process improvement to the agriculture industry. So I did a bunch of projects. I worked a lot with Driscoll's. We did projects with farmers doing leafy greens like arugula and spinach. We did the big produce coolers, looking at the workflow within those warehouse environments, lots and lots of different projects within that agriculture space, which was really fun. And I did that for about 6 years. And then last year in 2020, I transitioned to my current role, which is a dietary supplement manufacturing company here in Scotts Valley. And my title is industrial engineer. And it's a very traditional industrial engineering role where, I get to go walk out on the manufacturing floor and implement process improvement, talk to operators, and identify opportunities to streamline their work or make their work easier. If we make these big batches of our products and there's significant yield loss within the process, looking at where was the loss, why did it happen, how do we minimize that going forward. And I've been there for about a year now, and just having a ton of fun in that role. So recap: high school, Cabrillo, San Jose State. Took me a really long time to graduate because that balance between school and working. And then I've essentially had three jobs since graduating. One was in modeling and simulation within the air traffic or aerospace industry, I guess is a more generic term. And then 2 was consulting, engineering consulting in the agriculture industry. And then now traditional industrial engineering in a manufacturing environment.
Wow, it seems like it's so diverse on the things that you've done. It's really, really cool. Thinking at some of the projects that you've worked on, regardless of whether it was one of your 2 internships or during the 3 jobs you've had, could you give us an idea of some of the projects that you really enjoyed or projects?
Yeah, so one of the projects that I really enjoyed from the consulting job in the agriculture space was a farming company hired us, and they had installed a new irrigation system in their fields, and we're finding that the irrigation equipment was breaking. So they were having to, replace parts constantly. And there's a cost associated with that. There's time associated with replacing those parts. And so we went out, my team, and observed, how they were installing the irrigation equipment, how they would remove the irrigation equipment from the field, how the tractors would move in and around the irrigation equipment. We looked at the broken parts and identified the most common type of break, and then figured out what was causing the damage. And then could bring in like the tractor operators and come up with solutions for how we were going to prevent them from continuing to break all these parts, right? So looking at the process, study the process, figure out the root cause of the problem, and then focus on how are we going to change the process or do it differently to address that issue. So that was a really fun project because I got to be out on the farm in my boots and, being outside. And that was a really, really fun one. And then I think more recently, I've been really enjoying facilitating what's called a Kaizen event. And Kaizen is a Japanese term that comes in this umbrella of lean manufacturing. But basically what it means is rapid process improvement. And so I will take a team of stakeholders, like, someone that works in manufacturing and someone that works in the warehouse, someone that works in production control, and all those key stakeholders. I'll bring them into a conference room, and we'll spend 2.5 days really focused on process improvement. And we'll spend, the first half of one day mapping out and identifying what is the process, and then what are the pain points, what is the root cause for those pain points. Let's brainstorm some solutions, maybe go out on the floor and actually implement some of the solution ideas, see if they work in a very concentrated, rapid prototyping type environment. And that has been really fun, really fulfilling. It's fun to see like actual change happen almost immediately, because sometimes engineering projects can drag on and take a long time to complete. So these kind of rapid process improvement sessions that I've been facilitating at this new company have been really, really awesome.
What sounds really neat to me is that you're engaging many levels of production, or not just talking to engineers, not just talking to managers, but also talking to people on the floor. In both situations, both examples that you gave, you're talking to the tractor operator, you're talking to the people on the floor. And I think that's really great because they have the most experience dealing with whatever it is that you're producing. So I really think that's really a great way of trying to figure out problems and solving them.
Yeah, that is key, right? Because as an outsider, I mean, I'm an engineer. I've got a, good brain in here, and I can look at something and figure out what's going on. But these operators live and breathe the work every single day. And often they're an untapped resource, right? And so if you can establish that relationship where they're willing to share information with you, that is how you really solve the problem.
Cool. Okay, so I guess the last 2 questions I have for you is, how has your engineering degree impacted your life?
Tremendously, right? I mean, I grew up in, a single parent household, and we just didn't have a lot of resources growing up. And so here I am as an engineer. I have a really really good salary. I'm financially stable. You know, that is something that I always dreamed of. I feel like it was one of my biggest motivators for pursuing engineering, was because I wanted to have a job where, or a career where I knew that I could get a job. I knew that I would get paid well. And it was, you know, a bonus that I loved what I do, but that financial stability and security was, I think, a huge driver for me, and I have definitely achieved it. I'm able to own a home here in Santa Cruz County, which is not an easy thing to do, but definitely my engineering career has afforded me that, you know, that benefit.
Okay, yeah, we hear that many times. It's really, okay. And then the last thing is maybe some words of your advice or wisdom to students who are just getting started in the engineering program.
Yeah, so I think I covered a couple of them already. You know, get all your GE requirements out of the way at Cabrillo as much as you can. When you do transfer to the school, to the upper, you know, state or UC or wherever you end up, make relationships with your professors, and don't be afraid to reach out to them and ask for support and build those connections, because they become part of your professional network as you advance in your academic and in your career, right? Going to work as an intern, if you have that opportunity, I think is really key, because you get to see what a typical job is like, and you'll find what you really like and maybe what you don't like, and that is all gonna allow you to make better decisions when you get to that point where you're kind of ready to leave school and start to go to work full time. So I'd say those, you know, are definitely my big tips. Yeah, I feel like I had another one in there, but I forgot. If it comes to me, I'll chime in again. Oh, I remember what it was. When I started at Cabrillo and the math and the physics classes started to like escalate and get harder and harder, I feel like I definitely hit a point where I started to doubt my ability to push through. And you know, I talked to Joanne, and I remember talking to Carlos from you know, one of the physics teachers, and kind of had that little push to just like keep trying. And I was able to move past that difficult point. And so if you go on to those upper division or those more difficult physics and chemistry and calculus classes, you know, don't be intimidated that the work is hard. Because from my experience, those were the hardest classes that I ever had to take, and everything past that was much easier. So don't give up if you find yourself kind of hitting that point. Push through, and you will be glad that you did, I promise.
That's such great advice, Katie, because I've had many students like that too, where they're just like, I don't know if I could do it. And you shouldn't start questioning yourself, because those are just tools that you have to kind of get through and use, but you probably hardly ever use
physics or the calculus. Statistics, you know, that's the one piece of math that I pull out of my toolbox a lot.
Right.
But I'm not doing integrals or whatever the rest of that stuff was.
Yeah. Well, great. Thanks so much. So thanks for telling the students about your path, both your educational path and your career path. And thanks for giving those tidbits at the end, words of wisdom. So
yeah. And if you have anyone in your class that is curious about industrial engineering and wants to get together for a Zoom or a call or a coffee, you know, just give them my contact information, and I'll be in touch for sure.
Okay. Sounds great. All right. Thanks so much, Katie.
Thank you. Bye.
Okay.
Good luck.
Bye. Bye. Hey, everyone. Okay, I'm back for real. I hope you're enjoying this class. I mean, I'm bringing a lot of people in.
Cool,
anyway,
too.
hope it's good. All right. Well, Graham, you're on, kiddo. So, Graham, are you going to tell him the story about when you, okay, so I'll tell it.
Oh yeah.
So
Let me tell him.
Do you want to say it or I'll say it? Well, actually, I have a story about both of them. So let me think for a minute. Oh man. So
You're blowing it, Joanne. Let me-
sorry, I have to remember. Okay, so Katie's sister's a nurse, and when I was pregnant, Katie came to me and said, Joanne, on a scale from 1 to 10, how much pain do you think you're gonna have when you're giving birth? And I said, maybe a 7. She goes, no way, it's gonna be so much higher than 10.
Yeah, I
That
would
was one
imagine.
story. And then Graham, you took my class, you took Engineering 5 when you were a high school kid, right? When you were 16. And
Yeah, I
you were
did.
like, boy, this bitch is too much work or whatever. What did you?
It wasn't, it was like, I was like, this lady is crazy New Yorker. Like, oh my gosh. So yeah, I also went to school in Santa Cruz, actually San Lorenzo Valley. So I grew up in Boulder Creek. It sounds like this class today is specifically focused on industrial engineering. Is that correct, Joanne?
Yeah.
So yeah, growing up, I was like pretty good at math, but I was really involved in sports, and school really wasn't my deal. I was kind of a little bit rebellious. I liked sports and other stuff like that. So in junior high, I was racing motocross, amateur motocross, and that was pretty much my focus. I was pretty blessed with that. I mean, we didn't have a lot of money growing up, but my parents definitely, my dad liked racing. So I kind of focused on that. And then I actually went to homeschool a little bit in high school to kind of support the fact that I was gone a lot of the time racing. And school really, at that time, wasn't very difficult for me. The reading and writing stories I didn't like. To me, it just seemed like a waste of time. So I actually dropped out of high school, and very shortly thereafter, I broke my shoulder 2 times in a row, and I broke a bone in my back, which was my facet, and it healed into my sciatic nerve. And I had no desire really to go back to school, but my mom was like, man, you need to go do community college. So I went to community college and did some math, like I think it was algebra 152 or 154. And I took an intro to engineering, basically because I was good at math. Everybody thinks you'll be an engineer. And that's when I met Joanne for the first time. And I remember just being completely overwhelmed I think I was 16. I took a California high school proficiency exam. I wasn't old enough to take the GED. And it was like, holy moly, this is serious. Like, Joanne really pounds into you, how serious engineering is. And let me tell you guys, you have the best college to go to at Cabrillo and the best faculty there, hands down. So I kind of jump around. So that was my first deal. And then I actually went off and I kind of got like, menial labor jobs. Like I split firewood, and then I was building houses, and I was making, decent money in Palo Alto, Menlo Park, Atherton. So I was on nice projects, building, several $1 million homes. And I really didn't have health insurance or medical or dental or anything like that. And it's like, so I got on through a buddy with a mechanical engineering company that did HVAC and process piping for clean rooms. And it was cool stuff, but I was still doing labor, right? I mean, like I'm cutting pipe and I'm fitting pipe and I'm brazing stuff. And I always liked hands-on things like that because I always felt like, hey, I'm out here, I'm doing it, I'm tough. And it was a very small company. There was probably 10 employees, the owner, an engineer in the office that did all the bidding and some of the technical stuff. And then there was a foreman for sheet metal and a foreman for pipe fitting. And this engineer would come out to the job site, and we're doing projects for like Fujifilm. One of the things I did was set up, a whole system of clean rooms for a company that was coming up with skin printing. So they're actually using like an inkjet printer, highly evolved, to do printing of skin using stem cells for people who were burned. So there were cool projects, but this engineer came out and he was middle-aged, probably my age, and he just screwed up everything. So that was when I was like, man, if this guy can get an engineering degree, I mean, I can too. I don't want to do this forever. So I asked him, I go, hey man, like, what's your deal? And he actually went to San Jose State at night, and he did night school. And that's how he put himself through. So I go, you know what, I'm going to do it. So I started, and I was working, it was like a union job. So I was working from 4 a.m. to like 2 p.m. And then I would commute over the hill back home. I was living in Scotts Valley at the time. And I would go to Cabrillo and do night school. And I just did my very first math classes. And I got through like 152 and 154. I mean, I had nothing. I didn't do chemistry because I was a glorified high school dropout. So the company worked with me pretty good so I could do that stuff. And I actually, at some point, it became, you know, okay, you got to do to get financial aid, which I hope, you know, if all you guys are eligible for, you're staying on top of getting your financial aid. I mean, that's just a direct investment that, you know, the state, the government is going to make in your future. So if you're not staying on top of that stuff, like get on it, because at the end of the day, it's money that's out there for you to take advantage of to better yourself, which betters our whole community, which makes a better life for your kids and your family. And it's just really, really good. So please make sure there's counselors at Cabrillo. So I did that, and I had to get, you know, 12 units, you got to get good grades. And I just got really serious about it. You know, at the time I was 26, I had been out of school for a long time. I'd experienced, you know, some ups and downs in life. And I started enjoying it. And I went through and I did, I want to say at Cabrillo, I want to say 14 math classes. So I did 152, 154, trigonometry, the 3 calculuses, linear algebra, differential equations. I did all the physics, the chemistry, and I ended up transferring to UC Berkeley. So I think a lot of people, Katie touched on it. Every time I come and hear other alums speaking, everybody says the exact same thing that I'm going to tell you right now, is that Cabrillo prepares you better than you think. So if you're thinking I'm at a community college and I'm going to go to San Jose State or to Cal Poly or to UC Davis, UC Berkeley, wherever you're going to go, you're getting such a good education there. So please take advantage of it. Take advantage of your instructors, your counselors. You know, always you're going to have certain individuals who might be busier than others and have, you know, things have changed a lot with the pandemic. But I think that if you do your homework yourself, check on, what is it? The transfer agreement, all these different things you can do. Assist, it was assist.org. Is it still assist.org? Joanne? Okay. And just make sure that you're planning academically, right? You know, the first industrial engineering video that we watched, I mean, I was like, good God, bam, let me slam my head against the wall here. It makes industrial engineering sound miserable. Joanne's touched on like the pizza place downtown that, you know, makes her stomach turn because the inefficiencies. Everywhere I go is like that. My wife turns to me, she's like, they need an industrial engineer. She's like, you could really help this place. So there's a lot of opportunities out there for engineers, and like big data, statistics. The guy had said like, you're not going to do a lot of advanced math as an industrial engineer. I disagree with that. Like when I got to, I didn't really know what I had in store, but when I got to UC Berkeley, I thought I was pretty much done with my math, but I had to do nonlinear optimization, which is like these, you know, multivariable, like, you know, kind of like a quadratic equations where you're trying to find like different maximums and minimums to determine mixtures, ratios, and blends for refineries. There's a lot of math that goes into that stuff. And they go through some of that stuff pretty fast, but really Katie had mentioned it, like statistics. You're going to take some more statistics if you want to be an industrial engineer. That's for sure, because you want to look at times and processes and variability and processes, and you really want to optimize that. Like you hear, I think probably everybody's heard of 6 Sigma, which has to do with standard deviations away from the mean, like 6 sigmas away. So in processes and manufacturing, they try to make a process as stable as possible, right? For a certain amount of money. You can design a bearing that has perfect tolerances and no deviation, but it's going to cost you a lot of money to manufacture that. And then if you allow a certain amount of variability, then your manufacturing cost and your tooling cost will come down a little bit. So when you design a process as an industrial engineer, you kind of want to know how much variability is allowed to go into that process. If you're designing like a front wheel for a children's bicycle bearing, as opposed to, you know, a high quality aircraft bearing for the Air Force, there's a difference there. So, and cost is really almost always the bottom line. So yeah, that's how I got interested in engineering, and how I kind of went through. So I transferred to UC Berkeley. Not a lot of students transfer to UC Berkeley. When I got there, I was really kind of amped. Lindsay Crawford, who I went to school with, she was the one who kind of pumped me up. I didn't even know about UC Berkeley. And in hindsight, in some ways, maybe it would have been better for me to go to a Cal Poly or a San Jose State, because I actually despise wearing a suit and tie. I've done that for a very small portion of my career. That's not the kind of engineer I want to be. I'm more like, I put on a hard hat, I go out and I want to work in the field. And I learned that at my first internship, where I worked for Bayer Pharmaceutical and I did process improvement for them. Sat in front of a computer all day, Excel, Microsoft PowerPoint, emails, you know, and it was ridiculous. It was horrible. I needed to do yoga every morning just to make sure that my back functioned properly. So, so I didn't really know what an industrial engineer was either. And I'll tell you guys right now, from my experience, just getting an engineering degree, like we always get so caught up on like, oh, what discipline do I need to be? Oh, I want to be a, you know, a chemical engineer, an industrial engineer, you know, a robotics engineer. For the most part, there is a little bit of overlap there. It's good to do your due diligence, listen to different speakers and talk to people when you go to career fairs. You definitely want to make sure that you're geared towards like computer science type of stuff. I feel like right now, when I graduated from UC Berkeley, I remember walking around the career fair, and every single recruiter asked you, and it was engineering specific, every single recruiter asked you computer science, computer science, computer science. They were looking head and shoulders above for people who did programming. To me, I have a programming, you know, skill set, but it's not what I want to do. And I just remember going, golly, man, I got the wrong degree. So I have never actually worked as an industrial engineer. My degree is industrial engineering and operations research. They touched on it a little bit in the presentation, where, I don't know if Joanne said this joke, but IE is an industrial engineer or an imaginary engineer. And then the joke is like, yeah, but I'm your boss. So for me, what I did is I actually went to work in the oil and gas industry. At the time, I was really close with my grandmother, who since passed away. My grandfather had passed, and there was only my aunt was able to take care of her. She was in Texas. So I took a job opportunity in Louisiana. It excited me. When I went to the career fair, they had like a great big oil rig, and it was in the middle of the ocean. And it was like, do you want to work in Kuwait or the North Sea and the Gulf of Mexico? And I thought, man, that would be so cool to be a part of those big projects. So I moved from Santa Cruz, actually from the Bay Area. I was living up in Berkeley at the time, and I took this job not knowing anything about it. And they gave me like a $10,000 signing bonus, and I was like, okay, like I'm rich. And I went to work, and I flew out there, and my wife didn't come. She wasn't my wife at the time, but we were, you know, had been together. I'm like, I'm gonna go fill this job out. Like, if I like it in a month, like we'll come down and we'll make it work. So took the job, company truck. They put me through 2 months of training. They had like their own academy, flew me to Houston, you know, developed a skill set there. I had to do a bunch of different training courses to be able to go offshore, you know, wear a respirator if you need to, you know, climb a rope, you know, fitness tests. So it was really different than a lot of way you think about engineers now, where you're like in an office in a cubicle with a clipboard. And I really liked that. I met people from all over the world, a lot of females, a lot of males. I mean, people from places where oil is big, you know, the Middle East, Ghana, you know, so it was a really, really cool set of people to work with. And then I ended up working in the Gulf of Mexico on deep water drilling rigs for like 6 or 7 years. And my curiosity, and you know, there was a lot of downtime too. So a part of that job is like, I'm gone for a month at a time and I'm on an oil rig and there's nothing to do except for work and monitor things. So I got curious about something and I actually developed an algorithm that was utilized by my company that really helps for steering wells and determining the wellbore position with a mathematical algorithm, an iterative algorithm. So I published a paper. I, you know, presented it to my boss. He was like, okay, let me send this to some people who know more about it. And through that paper, which was through curiosity, just the desire to tinker and to think about things, I actually met like the CEO of the, not the CEO, but the president of Drilling Services, a lot of high level key players at that company. And they basically brought me in and said, what do you want to do with your career? You've got so many other options than like sitting in the field. And I was like, well, I really like the field and I have a few other things that I want to do before I move in the field. So I actually became a radiation protection supervisor. So some of the things that they do when they're evaluating a formation they're drilling through is they use sensors. And there's a plethora of sensors. I mean, magnetic resonance imaging that they, you know, use the tipping rate of hydrogen to determine if it's oil or gas or water. And they do resistivity measurements with multiple propagation resistivity and acoustic sampling. They also use radioactive sources and they can bombard the formation with gamma rays and fast neutrons. And based on, you know, mathematical algorithms, how these things are measured and how many different molecules scatter, you can derive a lot about the formation. So it's not like you're just drilling through rock. Like there is in real time a lot of data coming up and you're analyzing that. So I became a radiation protection supervisor and I was in charge of the radioactive sources on location. And like if anything went wrong, like I was regulated by the Nuclear Regulatory Commission and it was a big deal. So I did that, and then a position came up in Germany to do research and development on a next generation tool that they use to steer autonomously these directional wells. So I asked my wife, I go, hey, you want to go to Germany? I got a job offer. And she said, yeah. So, I mean, Joanne talks about how this changes your life. I mean, I went from a kid stuck in Boulder Creek to going to Germany, and like, you know, they fly me over, they fly my family over, full health insurance. I had a new car every 3 months, a new rental car. My wife just probably got 5 tickets in France, driving all over. And I learned to speak a little bit of German. They actually offered me a job in Germany, and in some ways I wish I took it, but it was just too gray and I couldn't do it. And the other thing is, like, when you go to Germany or some cultures, it's very different. You'll learn that when you meet other students from areas. Like the Chinese culture is a certain way, the Indian culture is a certain way. In Germany, engineers are 100% happy to just design like a low voltage power supply for 20 years. And I'm not that guy. Like, I get bored, I want to work on different things. So actually, at the end of the year, the project was a little bit weird. We were getting purchased by GE at the time, the company I was working with. So there was a lot of push to get the project out the door. It was a big deal for the acquisition. And it became very political. I couldn't say that things weren't working. I'd have to say they were like in test, still in progress. And I'm pretty cut and dry person. If it's not working, I'll just say it's a piece of junk. You know, it's not working. So I actually ended up leaving the project. I told them in Germany, I said, I'm done. I'll go back to the US, but I'm not going to sit here and play politics on something that's not working. At the end of the day, my name is on it, and I'm telling the leadership it's not working. And they go, well, you drilled 3 wells with it. And I go, well, if we go drill a well for BP or Shell or ConocoPhillips, we'll drill the well, but it'll probably be the last well we drill for them for a long time. So, so that's one of the things that having an engineering degree can do for you. It affords you the right to utilize your own voice and reputation, you know, to say, you know, with certainty, like this is not working, or, you know, this is working. If you do, I would recommend, I didn't do it, Joanne recommended it at the time, to get your IET, your engineering training. Definitely do that, because later in your career to go back in and do the test, the equations, and it's not going to happen. So yeah, I think I covered a little bit of some of the projects I worked on. I drilled
Graham,
the
hang on a second, Graham. So
Yeah.
you guys all talk about the EIT next week when we talk about employment and professionalism.
Yeah. And I'll just add in, like, there is at no point, like Joanne, I don't feel like steered us wrong on anything. Seriously, like she hadn't, like, if I look back to the advice that she gave us, she didn't steer us wrong on anything. So I think your guys' success is greatly tied to her as well. You know, she's a great teacher, a great friend. I mean, the amount of students that just want to come back and say hi to her and speak to her. So, so engineering has impacted my life. When I came back from Germany, I went back to Louisiana, and it was kind of like an awakening for my wife and I. We're like, you know what? Like we've been in Louisiana for 7 years. We went to Germany. We didn't quite fit there, and we didn't really fit in Louisiana either. So my wife really wanted to get back to California. So I actually took another position with the same company in California, and I did that for about 8 months, and then I started my own company. So I started a company, and what I do now is I consult to oil and gas companies, specifically one, which is here in California, which is California Resources Corporation. And I supervise a drilling rig for them, or multiple drilling rigs. So I don't work on you know, the equipment on the rig. I wear a hard hat. I go outside. I typically live on the rig for 2 weeks at a time. I make reports. You know, if there's problems, I communicate that with the in-house engineers at CRC. I deal with the regulatory aspects. You know, there's a lot of different issues with blowout protection and well control and safety and efficiency. I plan material shipments to and from the rig, and I basically make sure that everything is moving efficiently and safely. And that is what I do now. And it's nice. I don't work for anybody else. I have people who I'm beholden to, but for the most part, it's a pretty relaxed deal. It definitely slowed down a little bit for me after the pandemic. So I think you guys are in a really good situation, because the economy is probably going to reset and rebound and restructure over the next couple of years by the time you're graduating. And this will give you a really good chance to see, like, what is the best field or niche that you want to go into. But don't ever think that you're shoehorned in, like, oh, I'm a chemical engineer, I gotta work at Pepsi and try to find out a new, you know, ingredients for the Monster Energy drink. You can do a lot. Like, you know, you can, like Katie had gone and, like, she did ag, and now she works for a small company. And your first jobs, guys, like, you're gonna feel like a small P maybe, you know, and it depends too what company. If you go to a big company, you're like lost in the mix. If you go to a small company, you're like wearing several hats. You're an engineer, you're a tester, you're a sales guy. So don't feel bogged down. That's the thing that engineering will get you. Like, you can go anywhere and get a job pretty good, you know. So where do you want to live? Where do you want to raise a family? These things are questions that you can afford to ponder, because employment won't be a huge major issue. It might be. I mean, the economy is strange. Everything is always weird. There's always different generational upsets. But with an engineering degree, I think you'll be standing on a pretty firm foundation.
You're awesome, Graham. Thank you.
No problem. Thank you, Joanne.
Yeah. any questions for Graham? I have the chat open, so if you want to write him in the chat, you can.
Yeah, no problem.
I like the idea what you said, Graham, is that you got an industrial engineering degree, but it would just show that you're capable of getting a degree and it's a technical degree, and then you were employed in something different, and then you had so many options and you just changed to suit what you wanted and what your family wanted.
Yeah.
It's great. And now you're working for yourself.
Yeah. That's, you know, I mean, you can't blame anybody when anything goes wrong.
Yeah, but you got the experience under your belt, so you're competent and it's great.
Yeah.
Okay, questions, you guys? And I could always, if you don't think of a question now, but you think of one in the future, I could get in touch with Graham as well. Graham, is that okay?
Yeah, totally. Absolutely. I'm always there to help out. If you're looking at different schools to go to, or, you know,
Okay. And Graham, where are you located right now? I know in California.
we're actually back in Santa Cruz,
You are.
but we're looking at property. We came back here after the fire because we were hoping to buy some property in Bonnie Doon. But
Yes.
the housing market here has gone just crazy. So we sold 2 houses in Southern California, and we're actually renting now on the west side.
Okay.
And we're maybe going to Sonora. So we don't know.
Okay. Okay, cool. Well, Sonora's nice too. Okay, I don't see any questions in the chat, so we're just gonna say bye, Graham, and then I'll get in touch with you if there are some questions, but thank you so much.
Thank you too. I hope everything's going good. I know I got that you were back in New York with your mom.
Yeah,
Everything's
I'm
okay.
visiting my mom.
Okay.
So,
Okay. Good.
yeah, everything's
Good to
good.
know. Okay.
Yeah.
Have a good day. Thank you, Joanne. Good
Okay,
luck,
bye,
guys.
Graham.
Hey, one more thing. You're always going to doubt, like at any given point, there's going to be a class that kicks your ass. Maybe multiple. And you're just going to have to like close, like engineering is hard. That's what, when I met Joanne, she's like, okay, guys, you got to be on and that. And I'm like, whoa, lady. She was like a drill sergeant. Just close your eyes, tell yourself, I got this. And that's all I did the whole time. I just kept telling myself, I'm going to be an engineer. 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 And it's such a big accomplishment. There was a girl who randomly, she was like graduating in front of me. So her family got a picture, you know, they were taking pictures of it, and they got a picture of me when I was graduating. And it's probably like the best picture I've ever seen of myself. It's such a big deal. And it's took me 6 years. Katie said it took her how long did it take, Katie, Joanne?
6 plus 2.5.
I was at Cabrillo for 4 years, but I got everything done. And then when I did apply, they couldn't tell me I didn't have anything. I had everything done. And Joanne made certain of that. So make sure to work with her and do due diligence and make sure you get all your stuff done, and you can do it. Anybody can.
Okay. All right,
Thanks,
thank you,
Graham.
Graham.
Bye.
Okay, you guys. All right, I'm bringing you back so I see you all now. How is everyone? Okay? We just have a little bit more to go.
So far, so good. Thanks.
Okay. All right. So I'm going to go back to sharing. Hang on a second. Not here. Let's see where I want to be. Yes, that's where I want to be. I got to move things. Okay, so, you know, a short overview of industrial engineering with that video, and then you saw introduced to Katie and introduced to Graham. So I mentioned James is another industrial engineering student, and he works on the manufacturing line. So even though he has a degree in industrial engineering, he's overseeing manufacturing. He could not come during the day because he's working, but he's coming to my 6 to 9 class tonight. So I will videotape him and then I will send to you guys. So there is a discussion. Let's go back here. Okay, do you see the class module right now? You guys? You see the
Yes, we see it.
class module? Sorry, yes or no?
Yes, we see it.
Yes.
Okay, great. Okay, just like you normally do in every class, you have a discussion item. And my discussion is very much like the chemical and materials engineering one, where I want you to watch some videos. So don't do it yet, because tonight, the presentation that Graham just gave, I'm going to stick in here for the 6 to 9 class. And then when James speaks tonight, I will stick it in here for your class. So you can't really do the whole discussion yet. So just hang on, okay? So the idea is that, let me go back to this. You could see the presentation again, you guys?
Yes.
Yes.
Okay. So James works at a company in Watsonville. And actually my husband works there too. My husband his name is Jamie Thompson. He's a mechanical engineer. He grew up in the Silicon Valley area, went to De Anza, which is the community college there, then went to Cal Poly, and he worked in a number of industries. He mainly is very creative and loves designing machines. So, oh, I spelled industrial wrong. Look at that. I'm just sorry, I got distracted. Oh, well, sorry for the misspelling. Anyway, he went to Cal Poly and then he worked as a mechanical engineer designing machines. The first company he worked at was in Scotts Valley, and they were making big machines for making silicon wafer chips. Then he worked for a company that made batteries. And now the company he's working for is called Smith and Vandiver. They're in Watsonville. They make bath oils and bath bombs and gels and shampoos and soaps, so all personal care products. And James was working at that company when he was at Cabrillo as an intern. And then when he graduated from San Jose State in industrial engineering, he got a full-time job there. So you'll hear from James, but you have to wait until I'm able to post the video of him. But what is really interesting is he's working on a manufacturing line, looking at the process and making the process better, which is what Katie called traditional industrial engineering. So you're going to hear from him. And then I wanted to give you a tour of their plant, but all the stuff they make is proprietary. So they really couldn't allow us to have a video of it. So instead, I went on to the show How It's Made. Some of you might have seen that show before. And they show you how to make everything. I mean, how to make baseball gloves, how to make this, how to make that. But the one I picked was candy canes because we kind of liked the whole candy last week. So I want to show you that. And let's see how, hang on a sec. Okay, do you see the YouTube site, you guys?
Yes.
Yes.
All right, so I'm going to skip the ad. And so, oh, wait. So I want to just stop for a minute. So on a manufacturing line, there are, see, look on the right. Look, they show you how it's made, Jawbreakers, candy, right? How it's made, flatware, how it's made, crayons. So this show, How It's Made, has zillions of videos. The machines that are used in the manufacturing are made by mechanical engineers, and often software engineers or electrical engineers because there's circuitry and software, or even mechatronics, right? Robotics. But the engineer who's in charge of the whole manufacturing line is a manufacturing engineer or an industrial engineer. So the equipment you see is made by mechanical engineers, but the process of going from one machine to another, that's all industrial engineering. So as you're watching this, if you're enamored by the machines, you probably want to go into mechanical or mechatronics engineering. But if you think the process of making the whole thing is really cool, like the instructions per se, the process, then that's more industrial or manufacturing. Okay, so I'm going to start this video.
Candy canes come in many different colors and sizes. Candy makers start by cooking up a big batch of sugar, water, and corn syrup. Next, they prepare a mix of starch and peppermint flavoring. As they blend together, the flavoring binds to the starch. The flavoring mix is emptied into the middle of the syrupy slab. Then the whole thing is fed into a machine that folds the batch repeatedly, using shovels and a plunger. This distributes the flavoring evenly. Cold water is piped into the shovels and the kneading table to cool the candy cane mix, so it takes on a stiffer consistency, which is needed for the next step, the automated pullers. These pullers stretch the mixture around a metal post. This action aerates the candy, turning it white. This batch will make 3,200 candy canes, but there's still a lot more work to do. The candy is rolled into a fat log as heaters warm it until it's pliable enough to shape. Next, they roll strips of red-colored candy. A worker stretches and folds it to widen the strip. Two of the red strips are arranged on either side of the white candy. The block of candy weighs 100 pounds, so it takes 2 workers to transfer it to a batch roller. The batch roller cylinders roll the candy thinner and thinner, dramatically reducing the log's diameter until it reaches candy cane dimensions. A torch moves across the candy to keep it pliable. The sugary batch travels between wheels that slim it down even more. The rope of candy moves forward in a wave-like fashion. This gives it some slack so it doesn't stretch as it moves through the next set of wheels. The candy rope moves through 2 angled belts that twist it, and a chain of knives cut the twisted rope to candy cane size. This production has been perfectly choreographed. Here, a roll of cellophane unwinds, and a device wraps it around the candy sticks. A blast of hot air shrinks the cellophane on the ends of the canes. Now it's time for these candy sticks to get their signature crooks. This machine, called a crooker deck, bends the ends. An overhead bracket brush gently secures the canes, because though they're pliable enough to bend, they're still fragile. There's a camera inside this robotic arm that spots the candy canes on the conveyor belt before the arm picks them up 2 at a time. It places them in cardboard packages by the dozen. It takes about a half hour to make a box of candy canes, but they're sure to come to a very sticky end in less time.
Okay. Okay. Okay, I'm going to stop sharing now. So, I mean, I think I could watch that show all day long on how a zillion things are made, and I'm really just amazed. And my husband designs many of that kind of equipment, you know, from scratch, which is pretty amazing. Sometimes the company buys some things, like things that put labels on boxes, but much of it is designed and built in-house. So there are companies in Santa Cruz County that hire engineers. So we have about 10 minutes left. So maybe less than 10 minutes. So maybe let's just go back and just do an overview on, hang on a sec, let me get back to the module. I have to move the pictures again. Okay, so in class 9, we looked at the slides, which just basically gave us the links to some sites and also just give us the whole schedule for today. You saw the video by Peter. You saw the slides again by Keenan. And then we saw Katie Griffin's industrial engineering talk. And then we saw how it's made, which is on here. Remember, the only assignment, there is no homework assignment for this week. The only assignment is the discussion, which is watch some videos and then write something in the discussion. But remember, don't start it yet because you don't have James's video yet, because James is speaking in this 6 to 9 class tonight. So wait until tomorrow before, I could post it. And then there's just a reminder that I did at the beginning of class of these 3 projects, and they're all due our last week of school. And then in terms of next week, I'm going to be with you next week again. And we're basically going to look at employment statistics, talk about professional engineering licensing. That's what Graham was alluding to, ethics, social justice. And there, just to recap, there will be 1 homework assignment, but it's going to be optional. And it's going to count as an extra credit to count towards a missing homework, a homework you missed, or replace a lower grade. This is all nothing. This is just, these are not posted. And then just a reminder that our last class, which is April 15th, you are going to be mentioning a highlight of the interview that you did, and then also bring your mobile too. And then you have this project due. All right. So those of you who haven't interviewed with me yet, which again, not interviewed with me, sorry, met with me for 30 minutes. So Alejandro, Carlos, Crystal, Jasmine, Kevin, you guys should come and see me this week during my office hours. And my office hours are posted on the Zero module under instructor. So I guess just the last time, if you're ready to go, you could go. Otherwise, if you have, some questions for me, ask away. And I do have
Thank you, Joanne.
You're welcome, Cody. Thank you.
Have a nice weekend.
Yeah, you too.
Thanks, John.
Yeah. Okay, see ya.
Thank you. Thank you.
Okay, see ya.
I had emailed you, but I have a dentist appointment next week that I scheduled 6 months ago, so I won't be able to come for next
That's okay.
class.
So do you want to come? Let's see. Let's make appointments, Ken's. Wait, Ken's, you met with me, didn't you already?
Yeah, I actually did interview someone already.
Oh, okay. So do you want to just meet with me? What do you want to meet with me about?
Oh, no, I'm saying that I had emailed you because next week I can't come to class because I have a dentist appointment
Okay, yeah.
that I scheduled like 6 months ago, and I
Okay, sorry, I wasn't
remember.
understanding you. Yeah,
No, it's okay.
Yeah, Ken's, don't worry about it. What Pretty and Carl and I built into class is the reason for the disco. Basically, your attendance or participation is worth 20 points. Students get 5 points for being in class, and the other 15 is coming from the discussion. So that's all you have to do is watch the video and then do the discussion for next week.
Okay, sounds good.
Okay.
Thank you.
Great. Okay, see ya. Hey, Kevin,
Hi,
how are you?
good, and yourself?
Good, great. So you have not met with me yet, right? Is that correct?
Yeah.
Okay, so do you want to pick a time?
Yeah.
Okay, so what works for you next week between my office hours are 1 to 2 California time. Monday, Wednesday, Friday. Monday, Tuesday, Wednesday, Friday. What would work for you?
I could do Monday.
Okay, great. So come by at 1 o'clock then, okay?
Okay.
Great, I'll see you then.
What do I have to bring anything or
No,
no?
no.
Okay, thank you.
Nothing. Okay, I'll see you then.
Okay, thank you. Have a good weekend.
You too, bye.
Bye.